So first thing we'll talk why Scala itself was developed. Okay. So first let's find Scala. So by you just doing Scala language. Okay. So if you just type Scala, you might find something else. But if you type Scala language, you'll find the right website for this. So it is nothing but scala-lang.org. So go there. Okay. Now, you want to read something, you can look at this. See, for example, when was this started? Let's see, designed by who and all that information you can see. Let me open this here. I'll show you when Scala started, right? So first appeared about 16 years ago. It's not new. Okay.
Okay.
What happened is Java, when Java was developed, Java itself was developed for multi-threading, meaning you have one PC, one CPU. On that CPU, you can do a program. You can run a program in multi-threads, meaning a program can run multiple threads in parallel.
Okay.
So this is to make use of your CPU and run efficiently, meaning you're not running one thread, but you can parallelize your program at the CPU level. So your program can run multiple threads. Okay.
Okay.
Now each thread, when it completes its job, it will come back to the Java and say, hey, I'm done, right? Then
Yes.
Java can decide, that is your program can decide if it wants to spin up another thread to do some other job. Okay, so this is just to efficiently schedule your time with your CPU, single CPU.
Okay.
Now that particular scenario was very good for the time it was designed. Java wise, everything is okay. But soon we started seeing these distributed systems. So they said, Java itself is designed for multi-threading, whereas we need a little bit more. Okay, we need a easier language. And let me show you one of the examples I always think is better to show is a simple Scala word count program. Okay, so if you look at there are a lot of things you can read online, but what I want to show you is this program. See, if you have to count how many words are there in the given file or whatever context, right?
Okay.
So if you look at this left side is the Java program, you see how many lines they wrote.
Correct.
Okay, but whereas Scala
Yeah.
code is on the right and Scala code looks like one line
Yes.
compared to same thing written in Java. Okay, so first thing is Scala is a scalable language, meaning you can not only just think about single CPU multi-threading, but this is scalable to multiple distributed systems. And then language itself is written as functional language. Okay.
Okay. Okay.
Now, what they did is in the beginning itself, they came up with this idea, which was not called lambdas in those days, but now they're introducing it as lambdas and all, but Scala had it from the beginning. So Scala language must have evolved a lot. I don't know the complete history. And today, what happens is if you want to write Java code, it is very difficult. And compared to Scala code is like one line code compared to what Java can write in like 10, 20 lines of code. Okay.
Okay.
So when you write less code, it is easy to write. And also it is easy to maintain and debug. If at all you have a bug, you just look at 4 lines of code compared to 100 lines of code in Java. Okay. So how do we get started is basically go to Scala lang.org and then you get the package. So basically I'm just going back here to the Scala language website. and then click on download. Obviously, you can read more about Scala. Now, when you go there, okay. So one more important thing about Scala itself is, again, Scala itself requires Java to run because Scala is running inside your JVM. Okay.
Okay. Yeah.
So that's the reason you need JVM, because Scala program itself is JVM program, Java program, or inside runs under JVM. Okay.
Okay.
Now what you do is you go through this and you will see there are a lot of different options here to download. Either you can download it as a Red Hat package manager file, or you can just get it as the TGZ, which is the tar zip file, and which is
Okay.
suitable for like anything like Mac OS or Unix. So you can see that the whole compiled language is just a 21 megabyte file. So it's pretty small. And once you get this TGZ file, it's same as your tar file. Okay. So now what I
Okay.
did here on this box, if you look at one of my Linux boxes, I have this software downloaded. So you can see I
Okay.
got 2.13.4, and I was just showing you on the site, it is the same version. So obviously I have the latest version.
Correct.
Now what you do is you just unzip it, just star minus xzvf, and get the software unzipped. And then you have this folder called Scala 2.13.4. Okay.
Okay.
So this one, just like any other softwares, you have a bin folder, doc folder. Bin folder is where your executables are. So you go into the bin folder, you can look at it, and then you see there is this Scala and Scala C. Scala C is the compiler. Okay.
Okay.
So then you say file Scala, and you can see how it is built. Like it's a ASCII text executable, meaning it's a shell script. It's not even a executable on its own. What it does is when you run Scala, it basically launches JVM and starts your Scala interactive program. Okay. PWD, you see I'm already in the Scala folder in the binary directory bin, and then I'm going to run Scala. Okay. So this is how you start Scala, and we'll wait for a second. So because it is loading. Now, what you notice this, it's a very simple thing, right? It says welcome to so-and-so, and it has detected that you're using OpenJDK version so-and-so. Okay. As I said, Scala itself requires JDK or JVM. That's how it runs. So that's why you need that as a prerequisite. And then what you can do now is to interact with the Scala shell. You can do help. Like everything, Scala command requires a colon in the beginning. Okay, so I just introduce some unwanted characters there. Let me do a help. And you can see the help itself is printed. Okay, this is a Scala shell where you can type your commands. Okay.
Okay.
Now, let me introduce you to something called REPL. So the word REPL, what does that mean is read, evaluate, print, loop. Meaning you read an instruction, evaluate what to do with that instruction, print the result, and then ask the user to give the next command. So that is called REPL.
Okay.
Okay. Now, example for REPL is there is Lisp, IPython, Scala, Spark Shell, and PySpark. So those are a couple of programs which implement the REPL. So right now, what you see in Scala is nothing but REPL. So the shell, the command prompt it is waiting for. So what you can do is clear. Okay, hold on. So you can do clear, right? It gives error because there is no clear command. Okay.
Okay.
So there is a Linux command which is Control L, which clears the screen. It has nothing to do with Scala. Control L.
Okay.
Okay, now what you do is, I talked about read, evaluate, print, loop. Okay, so what does that mean is, now Scala is ready to take your instruction. Let's say, for example, 1 plus 2, that is your command you're giving. That is reading your input. It will do the evaluate, which is calculate the value, and then print the result. You can see the print result has come out. Now it has come back to the prompt again, waiting for you to give the next command. Okay.
Okay.
So read, okay, evaluate, print,
Okay.
loop. That is what REPL is. Okay, all clear?
Okay.
Very good.
Yeah, clear.
So
Yes.
any language by default has something called data types. Okay.
Okay.
So in because this is a Java-based language, there are a lot of Java-based things we have to understand here. Okay. So anywhere you write a language, you write hello world first, right? So as soon as you type hello world in double quotes, as soon as you put something in double quotes, obviously it's a string.
Okay.
So what it did, see, when you gave hello world in the double quotes, it took that string, it declared a variable called string. Okay. So what I want you to notice is there are like primitive data types, which are basic data types. So if you type 10, enter, it takes that, creates an integer data type variable and assigns it 10. Okay. Then you can do 10.2 and you can see immediately it will make it double because you need floats and all, right?
Okay.
Now you can do 12 plus 2, which is an integer. So I'm talking about the result. Keep looking at this result, how it is able to infer and identify what data types you're dealing with. So as soon as you do 10.2 plus 6, you can see it will create it as a double. Okay. So it is able to handle the primitive data types, which are basic everywhere: strings, ints, doubles, floats, right? It handles them.
Yeah.
Now, in general, when you do this hello world, let's say 2 strings, you want to add 2 strings. Okay. Like you added numbers earlier, now you're doing addition of strings. What it is going to do is just as you expected, it concatenates the string and then results in a new string. Okay. Now, whatever is the basic data types, which are like string, int, double, those things are called primitive data types. Okay. Now you can do something with those basic data types. Then in Java, basically they have something called objects. So what you can do is you can define an object and then you can define methods on it. Like it is extensible, meaning it's not very basic. It can do a lot more than basic stuff. Okay. So you can read a little bit more about primitive data types versus objects. So this is more like a homework. So what you do is you read about these things. Okay, primitive data types versus objects.
Okay.
Okay. Now let's talk about something called variables, right? Versus, I want you to notice something called val. Okay. In Scala, we are going to use this val a lot. So I want you to understand what is the difference. So let's see how we can identify the differences. I'm going to again clear the screen. Okay. Where x equal to, I was not doing this earlier, but I want to show you something. Hello world. And then I just give an enter key, and you can see because I specified define a variable called x. So that's what it did. And then I gave it a string. So it declared it as a string. And then it assigned the value, initial value I gave. Okay. Any language will do that. Now, what I want to do is, because the x is already existing in memory as a variable, I can do x equal to x plus. Okay. I'm going to modify that x in place. We love Scala. Okay. Then I'm giving an enter key. See what happened to the message here. So it says X got mutated, meaning mutated means it changed. Now, how do you print X? By just doing X and enter. You can see what was stored inside the X. Okay. So initially it was hello world. Then we added we love Scala. So the new string is that whole thing. But when I said just X, it printed that value. But what it did actually is it created a new variable called val.
Yeah.
It named it as res9. It's a string value. And then it assigned whatever X had. Okay.
Correct.
Now,
Correct. Yes.
imagine you have this X, right? Now, you see this res9 also got created.
Correct.
So let's do res9. What is stored inside res9? It shows what is stored in res9, and then it generates a new value again, res10 and string. So if I keep doing res9, it will keep on printing. But if you notice, the res12 got created now.
Correct.
Res is nothing but result. Okay, result 12. If you run it again, 13. So on, so on.
Okay.
Now what I would like to do, let's say latest value is res13. Okay, equal to res13 plus I want to add something new. Say for example, I am testing more with Scala. Okay, I don't want this starting dot. I just want to put like a dot at the end. Okay, so you're manipulating the string.
Correct.
Okay. Now, I want you to notice initially when we did the same thing with var, it got mutated, but now it gave error. Okay. What I want you to understand here is val itself is immutable. So val itself is immutable. What does that mean is variable can mutate. Okay, meaning you can change value in place in memory. Okay, and I was telling you variable can mutate, meaning you can change the value in place in memory. Meaning if you had a piece of memory, whatever value was inside or whatever string was there, whatever number was there, you're able to do math, change it and mutate it. But val itself is declared as an immutable object, so you cannot change val. Okay, so let's write it as, okay, so val is nothing but value, but we'll just call it val for now. Cannot mutate. Okay, so remember that it cannot mutate. So that is the reason it is immutable. So what we'll do is we'll write it as immutable. You cannot change. Okay, vals. Now I always talk about this immutable and why these new languages, all these things you see like Cassandra, Spark, all these depend on this immutable stuff is because if you allocate a memory, internally what happens is, and we used to deal with this 20 years ago, what happens is there is a memory allocation. In C, we used to call it as malloc, meaning allocate memory for this variable. Then what happens, you allocated, let's say 5 bytes. Okay, in 5 bytes, you wrote hello. Now what we used to do in those days, we have to modify that hello. We have to make it hello world, meaning you need some more characters space. Then we used to
Okay.
modify that malloc, and then imagine you have to reallocate and move the memory. Okay, so reallocate like 15 characters, 15 bytes of space, copy the existing memory to new memory. So there is a lot of memory operation happening. And then when we are done using it, we used to call something called deallocate. So just like memory allocate, we used to memory deallocate. Okay. So why we used to do all that at that time, 20 years ago, 30 years ago, 40 years ago, C, C++, all those languages were written in such a way because memory was so expensive. Okay, so the system I started with the first time when I saw a PC had 4 kilobytes of RAM. So we have to make sure that we are not wasting any memory. Operating system itself needs 640 kilobytes, and then you have 640 kilobytes is for Windows, but 4 kilobyte memory. What we used to do is we used to boot with a floppy disk, then we switch it to another disk where we used to do the C programming, then we have C compiler in a different disk. So we used to switch these disks just to get our job done. Okay. Now, in those days, memory was so expensive, so we used to have very controlled code about this memory allocations and memory deallocations and all that. It was very expensive. The operation itself is expensive to allocate memory and deallocate memory. It requires CPU time to do that. Now, because memory itself has become so cheap, now you have systems with 16 gigabytes of memory, which is general laptop, or your cell phone might have more memory. Okay.
Yeah.
These cases, why do you even care about using the existing memory? You just create a new object. Who cares? So new allocation is very easy. So you don't change the existing value. Instead, you create a new variable and assign whatever change you want to assign it to, right? You keep allocating new objects. Now, Java-like language, what it does is it keeps track of your variables, and if you're not using a variable, it can do something called garbage collection.
Okay.
So GC is by default in Java. If your program is not using something, it will do the cleanup. So you don't even have to worry about deallocating, right? You just allocate, use it, and you don't even need to throw it away from your program. Your GC will take care of it.
Correct.
So that is the reason all these new languages coming up, they use something called immutable because you just create and use it. Who cares about deallocating, managing it, cleaning up? All that is taken care by the platform.
Okay.
Okay. So that is the reason we have this immutable memory sets, or I don't know what to call it. But here in this case, Spark or Scala by default uses everything as immutable values. Val.
Okay.
So always when you're working with Scala, remember to check whether it is a var or a val.
Okay.
Okay. Val cannot change. It is immutable. Var can change. It is mutable. Okay. All good. So once you get this small val versus variable into your head, we can continue with the actual Scala language itself, because so far what we're discussing is we're just trying to wrap our head around primitive data types, objects, and how they get declared in the memory. So any language you see, first thing they will teach you, oh, there is something called for loops. Okay. So let's talk about for loops, because these are very basic, like, any language will require this. So how do you write a for loop, right? See, for example, if you imagine this is Java, first you have to declare, you have to import a lot of packages and stuff. Here I'm going to just write for loop. I don't care about declaring anything. Okay.
Okay.
So what do you do for loop 1 to 10? Okay. What do you want to do with it? Print ln, print line I. I is what the variable is going to loop. Okay. So if you run this, right, it is
Okay.
read, evaluate, print, loop, REPL. So what it
Correct.
did, it just basically generated 10 values. That's all. Very simple.
Correct.
You
Hmm.
give an upper key, just like bash, you have this, and you can run it printed. So you see a print line and a print command, pretty straightforward. You don't have to do any declaration. You just start with your for loop, do what you want to do, and you're done. The whole for loop is written in one line. This is the beauty of the language. Okay. Now what we want to do, because this is pretty small program I wrote here, right? But
Yeah.
we want to do a little bit more advanced stuff. Let's say, for example, I would like to declare a var. So var means it is mutable. Okay. Let's say
Okay.
number list equal to, I would use a for loop. Okay. I,
Hmm.
same concept is like, say, I would say 500 to 505, some numbers. Okay.
Hmm. Hmm.
Now, instead of printing, what I would like to do is actually I would like to take each of that I and send it into that num list I'm creating. Imagine that's an array or something like that. Okay.
Yeah.
So I'm going to do yield. So yield is written this way, yield I.
Hmm.
Okay.
Hmm.
So take each value and then store it in that num list. Okay. Now what I want you to identify here or notice, okay, it automatically creates the object called var numList. That's what it declared. It is calling it as indexed sequence, that is object of data type int. Inside it is storing ints. There is an object called vector. It's a vector object. It has these values which got generated because of the for loop. And numList now contains these indexed sequence integers. Got it?
Okay.
Now, this is what I mean by objects. These are not primitive data types, right? See, primitive data type is int,
Okay.
but now you're dealing with the indexed sequence of integers. That is the object.
Hmm. Okay.
Now, what you can do with the object is, let's say, now you stored something in your num list. Okay. If you do num list, right, what it will do, it will just create another val,
Well,
is result 16. It
correct.
created a new indexed sequence int, took that vector and placed it back into res 16.
Correct.
But
Yes.
I don't want to
Results.
actually, I don't want to print it. I want to actually take each value and do something, right? So what you do is num list.
Yeah.
Okay. Now, interesting thing here is if you type a little bit and then hit tab, it will automatically print the remaining. Now, imagine if you had multiple num lists in memory, then it will ask you which one you want to print. Okay. Now let me demonstrate that. If you put a dot, because with this object you want to do something and you don't know what methods are available, you press a tab.
Okay.
Okay. Now what it is saying is for the tab, there are 180 possibilities, 45 lines of output. Do you want to see?
Okay. We will see.
You can say
One minute.
yes, no. Okay. Now
Yeah.
what I would
Yeah.
like to do is I don't want to see 180 possibilities. I want F. I will type F and then tab. So
Okay.
whatever possibilities are there with F, show me those.
Okay.
So now it is showing you all the functions possible with it. Okay. All the
Correct.
methods. They call it as methods because there is object dot method. Now what I want to actually do is for each. So I'm going to type for E, and you see how it is like as I'm typing, it is decreasing the number of outputs.
Correct.
And then I can hit a tab to complete it. Okay. Now what I need to do, so in the num list, for each of the values stored inside, I want to take it and print it. So the syntax is just like for loop. I'm going to take, say, for example, each of the value, I want to just call it as X. And I would like to do this print ln. You remember print ln X. Okay. Now, when I'm closing brackets also, you can see that it highlights which bracket it is closing syntax wise.
Yeah.
Then notice it again. Okay.
Mm.
Tells you which one. Cursor tells you which one you're closing. So this is a pretty straightforward mechanism I used. I stored some values in an object. That object is nothing but it's an indexed sequence of integers. Internally, it is a vector. I don't care what is vector right now. I want to take each of the element and print it. Now you could do just print instead of print line, and it will just
They
print
will come in one line. Yeah.
because it's not separated by line. Okay.
Mm.
Pretty straightforward. You take each element and do something. Now,
Correct.
same example in a little different way. I was using numbers. And now what I'll do, I'll create a var y, assign it some value. Okay. I will say hello world. Okay. Pretty simple. Sorry,
Okay.
let me do one thing. I'll remove this extra characters here. Okay. So now we have a y in memory. Now what I would like to do with that y is an object of type string. Okay. Y dot for each. Remember that for I pressed a tab, it filled it in brackets. What is that I can do? Okay. Tab. And it is saying now you can do 394 things with it. Okay. You can click tab and it will show you all the things possible with it. Okay. But now what I want to do, I actually know. Let's say, for example, each character, okay, I press C, okay, declare it as, each character, just like numbers in the previous example. I want to print ln C. Cool. So you can see the output printed in, like it took each character from Y and printing it as separate line. On each line, it is printing one character. Now, if you don't do the print ln, instead you do print, it will print like normally.
Each character.
Okay, all good.
Mm-hmm.
Now,
why you used x before for each x print x?
That was the previous example. There is no reason that is called x or c. That's the reason I'm saying you don't declare c. C is nothing but a character. X is nothing but a int in the previous case, right?
Okay.
Don't declare C.
Okay.
You just use it. Scala will take care of it. It will know what to declare, how to undeclare when it is done, and then what to do with it. Everything it knows. Okay. So far there is nothing special. Actually, I didn't even talk about the basic Scala. Okay. Scala's power come in the next command. You will see. Okay. So in the beginning, I told you, right? You write less code. That is how the language becomes powerful. Okay. Now let me do one thing. Let me clear screen for no reason. And then I'm going to use this just to show you. And then I'm going to show you the new method. Okay. Y dot for each. Nothing special, right? Just like the previous command. You know, what do you want to do with this for each? You want to print. Okay. So what you do, print in brackets, you write an underscore and close the bracket and close the bracket again. Okay. So I'm saying why declare C? First of all, it knows what to do, right? So for each, print it. And then why I put that underscore in the brackets is underscore represents whatever it is.
Okay.
If it is a number, you declare a number and print it. If it is a character, declare a character and print it. Who cares?
Okay. Yeah.
You see what it did?
Okay. Yeah. It is.
So I'm going to do ln like this, right? Just okay.
But when you put, that now it is not giving any result set, right? I mean, it is
No,
not
there is
assigning to any
output
val.
here. You see this output?
Yeah.
It is running the
Oh,
function on top
yeah,
of
it
your
is
object.
correct. But it is not assigning that result set to
No,
any val.
because in the
Mm,
previous, if you do just y,
mm,
because it is reading y, it doesn't know what to do, right? Evaluation is
mm.
nothing but it is assigning that y to a temporary variable or val.
Okay. Okay.
That's why you're seeing that print again, right? But
Okay.
here I'm saying for y is a string
Mm,
object, to be more specific. Using
correct.
for each method, you print ln whatever is
Mm,
inside. Underscore
mm.
represents anything, whatever is there.
Okay.
Now, if this is the case, like I'm saying, you're supposed to write less code. Okay. Why do
Mm,
I even write this bracket and underscore? Let's get rid of that, right?
okay.
See what happens.
It is printing anyway.
That is the
Everything.
language power, right? You're
Mm,
you're not telling what to do with it also. You're just
correct.
saying why dot for each print ln. I don't care what is inside.
Yes.
And if you do
Correct.
print, it is just going to do print instead of println.
Mm.
Okay. This is Scala. This is the power of Scala. When
Yeah,
I
very
saw this
powerful.
first time,
Mm,
okay.
mm,
So when I saw Java first time, I said
mm.
this is interesting, but I cannot write Java. Okay.
Okay.
When I saw first time Scala, I said this is what
Mm.
I'm waiting for. This is what I can write.
Okay. Okay.
Because this is easy. You don't have to
Yeah.
learn much. Your code is
Mm,
less.
mm,
It's very
mm.
efficient. It works.
Correct.
Agreed?
Yes.
Okay. Now, how do we quit? So exit will not work. Control C will not work. I mean, it will work basically because it is running a colon quit. Okay. So how do
Okay.
you quit Scala is colon quit. Now let's talk about why Scala is important for us. Okay. Um, because we are Cassandra administrators and
Yes.
Cassandra is just a data store. You throw
Mm.
data at it, it will store. It cannot do ETL. It cannot do aggregations and business intelligence in place. So you need a tool like Apache Spark. Okay.
Correct.
Now let's go back and look at the Java world again, right? Java is a language. Cassandra is developed in Java. Okay.
Correct.
Scala
Yeah.
is a language. Scala is developed in Java. Scala is a language. Spark is developed in Scala.
Yeah. I got that flow.
Now let's look at what is Spark. So why we need Spark is, let's go to spark.apache.org. This is again another open source project under Spark. Just like DataStax support for Cassandra, there is a company called Databricks. Let me show you
Correct.
Databricks also. Let's just search for Databricks. So this is called databricks.com, and these people are the company which supports Spark. Okay, so you
Okay.
can make
Mm.
Spark as an enterprise and all that. They sell just like DataStax sells Cassandra. Okay, let's go back to the Apache Spark itself. Okay, let's look at one small image here, and we're talking about this piece here. Okay, so let me do control 1. Okay, so Spark itself is a platform. Okay, so they developed it this way. So this is Spark. Now what you can do with Spark is they have something called Spark SQL. So you can run like structured query language. There is something called
Okay.
streaming. You can stream data from a program and Spark can read that stream and do something with the data. They also have a machine learning library, so you can do machine learning AI, or you can do graph kind of workloads using Spark. Okay, so Spark itself is a platform which can do analytics, and it can do all these four things. Now,
Okay.
what they also did is, because you have to talk to Spark, right? Now, Spark itself is developed in Scala. So they use Scala as one of the interactive languages. They support Python, they support R, okay, and they support thousand other things. But you see this list, the first citizen inside Spark is Scala, because Spark itself is developed in Scala. And
Correct.
why Scala is important is because a lot of people who are doing functional programming, Scala is very easy to learn and start with, and very, very powerful. Now, don't get me wrong, Python is equally powerful.
Mm.
So what they said is, okay, a lot of people who are doing data analytics and all this AI kind of stuff, who call themselves as data scientists, most of those people, they learn Python because Python is easy to start with. Okay.
Okay. Mm.
Now, there are people who did lot of statistics and they use a programming language called R. So they said, you know what? We are supporting Scala, Python, let's support R also. And then there are so many other things it supports. Okay.
Okay.
Then what they did, okay, so what are all the other things it can do, right? So Spark is an engine, let's say, for example, on top you can have some other stuff here, like smaller things. It can bring data from different things, okay? One of them is Kafka. Let me actually write it here. So I'll call it as, so you can have top level Kafka. Okay, so
Mm.
if you are looking at this first time, there is something called Kafka. Okay, and let me introduce some more words which you might want to look at. Aka. Okay, you can go
Yeah.
read about these things.
Okay.
Now, what Spark can do, your data which is sitting in queues, which are in Kafka, it is able to read this via streaming library into Spark. Okay.
Okay.
Now that is how you will read it. Once you bring it into Spark,
Mm.
your data is here, right? Now you
Yeah.
can read that same data using SQL. You can do some machine learning on that data, or you can
Okay.
represent it as graph.
Mm.
So you see how your data came from Kafka. You did something. Okay.
Yeah.
Now you did some analytics on it. Let's say, for example, Kafka is where you publish your sales. I got one sale of the product. I record the sale, and then I take that data into Spark, and then I summarize. Let's say, for example, so far today, how much sale happened? What is the total amount? Okay. I
Okay.
got a piece of information, today's date, and this is
Mm.
the sale amount.
Mm.
Take that data and you can actually write it back into Kafka. You can publish it back to Kafka, or you can publish it to anything underneath here. Okay.
Mm.
So what they said is, from Spark, you can publish it to Cassandra, Hadoop, HBase, like this is for Hadoop HBase. Okay.
Okay.
So again,
Mm.
let me type here. This is also Hadoop database, right? Now,
Yeah.
when they say Hadoop, what
Mm.
does that mean is they can write it into HDFS. You can read about all these things, how they developed all this. Okay.
Mm.
So you can write your data, store it into Cassandra, Hadoop, or HBase, and then there are some of these which are called Mesos, Kubernetes, and there is something called Zookeeper, Yarn, all these words, like, you have to go research. So I was talking about Yarn, and there is also called Zookeeper.
Mm.
Okay, so you're going to research about all these things.
Mm.
What is Yarn? What is Zookeeper? What is Mesos? What is Kubernetes? Okay.
Oh.
Now, what what I can tell you is Spark also can connect to any of your Oracle stuff like that. So if you have an Oracle database, you can bring data from Oracle to Spark, do something with
Correct.
it, send it to Cassandra, send it to HDFS, send it to Oracle, or send it to Kafka. You can do whatever, right? Spark is sitting in between. How we as Cassandra administrators, what we are going to do with this technology, we are going to get data into our Cassandra. We don't care about Kafka and all that right now. Our application is writing data into Cassandra. From Spark, we are going to read that data into Spark platform and do something with it. And those result sets, we are going to write back into Cassandra, or result set can be published into Hadoop, or then your opportunity is just unlimited. You can do whatever you want, right?
Yes.
So what we are going to do with Spark is whatever is not possible in Cassandra, your analytics, ETL, you read the data from Cassandra and write it back into Cassandra. You want to copy a table which has millions of partitions. Within Cassandra, you cannot do it, but you can do it with Spark. So Spark will load all that into Spark cluster. It's in memory. You do processing, you remove the unwanted data, and then store it back into Cassandra into a different table. Okay.
Correct. Okay.
So that's the
Yeah.
reason we need Spark. So how do we get Spark? Very easy, right? You go here, spark.apache.org, download, and then you pick version you want. I'm going to go with the latest. Now, there is one thing we did not discuss is, I'm going to just mention, excuse me, Hadoop has something called HDFS, and then there is something called MapReduce.
Correct.
MapReduce is written in Java, and it is very easy to write a MapReduce code. So people, when they were using MapReduce, this person who created Spark, if I'm saying the name correctly, his name is Matai Zaharia. He is from Boston, MIT. And he looked at this project like, he was using MapReduce code and all. Said, this is very messy. I'm going to create a new platform where you don't need to write Java code. First of all, I'm going to make it Spark, which can run on top of existing Hadoop. It can run all your MapReduce code as is, but you can convert your MapReduce to Scala and then make it very easy to use. So that's where Spark started. Okay. So that's why you see this is pre-built for Hadoop. I'm going to pick the latest version. I'm going to say pre-built for Hadoop 3.2 and later. Or you can also get the source code if you want the Spark source code, because it's open source, right? Now, I'm going to take this package, download it. So again, it's a TGZ. It's a tar in a zip format. So what you are going to do, just like Cassandra, your Spark itself is running as a cluster. Now, what we are going to do as a Cassandra administrators, generally your Spark will run on all the nodes you have Cassandra running. So Cassandra and Spark are acting like a single cluster, and they can talk to each other. Each node has some data, and Spark is aware of that. So it is token aware, meaning if you are reading some data from Cassandra, Spark can actually read it from the node it is living on. So it is token aware.
Okay.
How they did it? It's all in drivers. So you see, I have one of the node, Doom 3. This one has the software Spark. Okay. And what you see here, my Spark 301 binary format, Hadoop, it is built for Hadoop 3.2. It's a tar in a gzip format. I'm going to just unzip it. That's pretty straightforward. Tar minus xzvf, and I will say software spark 3, and there you go. Give an enter key, it will unzip. Now, what you need to do, just like Cassandra, all of your nodes where you're going to run Spark cluster, you actually need to download this software and extract, keep it on the same folder structure so you don't have any confusions about where it is. Now, what I do is generally, I also create a soft link. Okay, so let me show you two things here. One is I extracted Spark software and then I created a soft link to it. So I just call it a Spark current. Let's talk about how we can configure our Spark very quick, and it will show us how to use it or build a Spark cluster. So you download software, you extract it, and then you create a soft link. Once that part is done, you basically go into the configuration folder. So you'll go into Spark current. Okay. Now in Cassandra, all of the nodes are master, all of the nodes are clients, right? In Spark, we have a master and there are workers. Now we also call them as executors, okay, who do the job. So master will give the job, distribute it, and then workers or executors will do the job. So each node can have multiple executors. One of the nodes can act like master. Now, what we are doing here is the Spark configuration we are going to look at. It's called standalone cluster, meaning we don't use any other software like Mesos or Yarn. We are just going to depend on what Spark can do for us. Okay.
Yeah.
Now, so by default, there is a conf folder. So basically, let me clear the screen, PWD, and look at the folders. Same like binaries, and then there is sbin, scripts binary, and then there is some data folder, conf folder. We are going to go into conf folder. So there is like six nodes. I'm not going to go through actual setup because it's already set up. I'm just going to show you all the configs we need to do. Okay.
Correct. Okay. Yeah.
So
Yeah. Yes.
I'll go into the conf. Now, what I'm doing is one of the node in the cluster, you need to pick it as master. I am on Doom 3, which is what my master is. Okay. So how does it become master is basically in the config folder, they give you basic templates, and then you're going to make a copy of the template and create the files. Okay. First thing we'll talk about is something called Spark defaults. So how do you get this spark defaults.conf is I made a copy of existing template file and placed it in this folder called conf folder. I'm calling it as spark defaults, spark-defaults.conf. Now, just to just look at what is in the conf file. Okay, if you look at it, pretty straightforward, very simple. There is a lot of comments. You can read about them. You can read the Spark documentation. What we need to declare is we need to tell where my Spark master is running, or what is the Spark master IP address :7077 is the master port. Okay. So this is the first entry we are going to make. Second thing is, as I said, each executor or worker needs some memory to be assigned. So I'm saying here, I'm assigning 512 megabytes of memory per executor, or you can also write it as, like, say, for example, you can give values like 1 gigabyte. Okay, you want to call it 1 GB. So what I was saying here, look at the Spark executor memory. I'm allocating how much memory to use for Spark executors, right? So here you can say either it is 512 megabytes or 256 megabytes by saying M, or you can also do 1 gig, 2 gig, right? Like this, 1G, 2G, right? Or 10G,
Yeah.
whatever memory you want to allocate per executor. So that is the
Yes.
executor memory you are assigning, where the worker memory you are defining here. Now, this last parameter, remember I told you that Spark itself is developed in Scala. Scala itself is developed in Java. That means your Spark can run both Java and Scala code. Okay. Now, you
Correct.
have a piece of code written in Java, you can use it in Scala, or you have piece of code written in Scala, you can use it in Java. You know why? Because both of them at the end are called bytecodes and they can run inside JVM.
Okay.
So they can call each other. Like you have a API written in Java, API written in Scala, and they can work together.
Okay.
Okay. So they're called interoperable softwares, interoperable. Okay.
Okay.
What
Okay.
I'm doing here with the spark.jars is Spark comes with some jar files, right? But some API,
Correct.
but it does not have
Yes.
everything. So you can plug your own code into it. So what I'm doing here is I'm giving it a Spark jar file, which is nothing but our Spark Cassandra connector. Meaning later on we want this Spark to connect to our Cassandra. It will use this jar file. Okay.
Yes.
Now what you're going to do is on your workers, you're going to create the same exact file. So you can edit your master, create a copy, and then send this same file to all nodes. Okay. So what you're defining in this particular configuration file, Spark defaults conf, you're saying this is my master. This is how much I want to allocate for each executor. And these are the extra jars I want to include whenever you run Spark. Okay, so let's talk about a few more config files. Okay, so let me clear screen here, and then I'm going to show you another config file called spark.env.sh. Okay, how I got that file is there is already spark.env.template, which was given along with the software. And now what I did is I made a copy, and here is the spark.env.sh. So this is just like Cassandra env.sh, which is basically a shell script which will run when you start Cassandra. Same thing here. When you start Spark, it sets up your environment variables. Okay. Now, again, on the master node, I'm just changing this spark.env. And what I'm going to do is just show you what is inside. Ignoring all the variables which you see here, I'm going to focus only on the last three variables which we are actually using. Everything else is commented out. Okay. Now look at these two things. Let's talk about the two highlighted values, which are like workers and executors. Okay. Other than that, we have one more parameter here, which is like Spark worker memory. Each worker is going to get 512 megabytes. On a larger cluster with more memory, you can have 1 gig assigned, just like 1G, 2G or something like that. Okay.
Yes, yes.
Yeah, so in Spark, most of the parameters you're tuning are all memory parameters, because Spark is all talking about running everything in memory, meaning
Hmm.
all your queries you're running, your data crunching,
Hmm.
all your data itself is sitting in memory.
Hmm.
Okay.
Yeah.
See, your persistent storage is Cassandra, which is permanent storage.
Hmm.
Your Spark is all in memory. That's why it is fast. Okay. Now,
Hmm.
there are two files we edited so far on the master. So let's just clear the screen and see what are the two files. Okay.
Hmm.
Now, one file we edited is this spark nu.sh. The other one is spark defaults.conf. These are the two files. Okay.
Hmm.
We need
Hmm.
to send them to all nodes. All nodes will have same settings. So you're going to copy to all other nodes in your Spark cluster, which will obviously we are on the master, so everything else will be worker. And the master node itself can also act like a worker. Remember that part. Okay.
Okay. Okay.
So I told you which files you're going to copy to other nodes. And then
Hmm.
we're going to talk about one file called
Hmm.
slaves. Okay.
Yeah. Correct.
Now, this file also, again, you copy it from the slaves.template and make it slaves.
Yes.
I
Yes.
don't like the word slave,
Hmm.
but we cannot do anything. This is how the technology was. It's a master slave architecture. So
Correct.
master is your node you're working on right now. It's a Doom 3 here is my master, Spark
Hmm.
master. What we are telling is the slaves, I would prefer calling them workers. Basically, in this file, what you're going to say is which are the other nodes who are going to act like your slaves for this master, right? So I put all the IP addresses here.
Okay.
Now remember what is required for Spark master to connect to all its workers and start them and stop them when required is passwordless SSH is required. Cassandra does not require passwordless SSH. Spark requires it. Now, if you don't
Okay.
have passwordless SSH, you can
Hmm.
still make Spark work. Only problem for you is if you have 100 client nodes or your worker nodes, you have to go to each node to start the worker or the stop the worker, which is just painful.
Correct.
Okay.
Very painful. Yes. Yeah.
So passwordless SSH is absolutely good thing to have. So you need to learn how to do the passwordless SSH.
Correct.
Okay, so what I did is three files. This is the only file which you don't need to copy to other nodes. You just keep it on the master, and master is the only thing which will use this internally. Okay.
Hmm.
Now, what you can do, look at one more folder here called sbin. Okay. Now, let me clear screen and say pwd. You can see I'm in the Spark sbin folder, and look at the scripts underneath. So this is one central location on the master where you can start all the slaves from here. You can start the master, or you can say start all, stop all. Okay. So most importantly, I'm talking about start all and stop all. Those are the two scripts I'm talking about. Okay.
Hmm. Hmm.
There are other things like, stop mesos, start mesos, stop thrift server. Again, that thrift shows up here again, right? See, thrift itself is like you cannot give it up. Cassandra had thrift. Now you're seeing it in Spark also. Okay,
That mesos you mentioned, that is also we are seeing it here. Stop mesos.
correct,
The one, yeah.
correct. So
I
mesos,
didn't notice before.
yeah, you have to read more about mesos, what it
Hmm.
is.
Hmm.
Okay.
Hmm.
Now, I already have set path. So let me show you how I did my path. So just to show you this bash profile, I added these two entries into my bash profile where I'm setting up where is my Spark home, and
There
I'm
is a Spark
including
home.
Spark
Hmm.
home bin and Spark home
Yeah.
S bin. These are the two
Correct.
folders
Win.
I'm including
Win
into
it.
my path. what you can do, look at one more folder here called sbin. Okay. Now let me clear screen and say pwd. You can see I'm in the Spark sbin folder, and look at the scripts underneath. So this is one center location on the master where you can start all the slaves from here. You can start the master, or you can say start all, stop all. Okay. So most importantly, I'm talking about start all and stop all. Those are the two scripts I'm talking about. Okay.
Mm. Mm.
There are other things like, stop mesos, start mesos, stop thrift server. Again, that thrift shows up here again, right? See, thrift itself is like you cannot give it up. Cassandra had thrift. Now you're seeing it in Spark also. Okay,
That mesos you mentioned, that is also we are seeing it here. Stop mesos.
correct,
The one, yeah.
correct. So
I
mesos,
didn't notice before.
yeah, you have to read more about mesos, what it
Mm,
is.
mm,
Okay.
mm.
Now, I already have set path. So let me show you how I did my path. So just to show you this bash profile, I added these two entries into my bash profile where I'm setting up where is my Spark home, and
Where
I'm
is the Spark
including
home?
Spark
Mm,
home bin and Spark home
mm.
S bin. These are the two
Correct.
folders
Bin,
I'm including
bin
into
8.
my path. Okay.
Correct. Yes.
Okay. Now, let's get started. So what we need to do is obviously we need to start our master and start our slaves. So there is a very simple script. Okay, start
Mm,
all dot sh. Okay, so
mm.
if you look at this, it tells you which script it is running. When I hit start all, so it is going to start the master, and then it is also going to start all the slaves or workers in
Correct.
different servers. Okay, so you can see
Yes.
all the
Yes.
IP addresses. It says I'm starting these things, and there is a master, and then
Mm.
each of these have their own log files, and log files are
Correct.
written in respective servers wherever they are.
Yes.
Okay?
Mm. Mm.
Once all of this has started, you have your master, you have your workers or slaves. They're all ready to go. Now, what we can do, we can use a browser window, okay, to see the
Okay.
master. So for example, I want to know how much memory is allocated, how many cores are there, the Spark master itself. Okay,
Mm. Mm.
what it does is the Spark itself, when the Spark master started, it has this website called IP address port is 8080. So you go to this, it shows
Yeah.
you the Spark master itself. Okay, so if you
Correct.
study a little bit, this is your Spark master. How many workers are there? 6 of them. We have 24 cores. Okay, you remember I assigned 4 worker cores and 4 executor cores. I think some multiplication happened here. There are 6 workers and
Mm.
24 cores. Okay. Then there is each
6.
core comes with like 512 MB memory, each worker, and you got 6 workers. So total of 3 gigabytes, right? And there are 0 applications running, 0 completed, nothing is going on right now, and status is alive. And you can see each worker. Now you can click on it and you can see what that worker is doing. Each worker comes with its own website also, like this. Okay.
Mm. Mm.
Now I'm going to go back to the master. This is the master. Now let's use this Spark, which is distributed across 6 nodes, and it has lots of power now to do our whatever we want to do, like the complicated, more complicated work we have, okay, which can
Yeah.
be done in a distributed way. Now, for this example, right, we are going back to doing some more Scala. I'm not really getting into Spark yet. We are just going to use Spark to do more Scala. Okay. Now,
Okay.
what I'll do, I want to show you there are 2 files I'm going to use here. So, your data, you cannot always have data as variables. You need to have data sitting somewhere. I have two files here, which are flat
mm,
files. Okay.
mm,
And I have them inside my software folder. And then you
mm,
see there are two CSV files I have. One is the movies file. If you look at
mm,
this as movies, I will
mm.
say, I'm not going to move, but I'll say uh, head. Head, show me 3 lines. Okay. So you see what it contains is it has
Mm.
a year and movie
Yeah.
length, how much time it
Mm.
runs. This is the movie name. This is a comedy movie, and this is Antonio Banderas is the lead actor, and there are some more actors, and then some more details here with the image Nicolas Cage something. Okay, so there are some
Yeah.
made up movies here. You can see different categories like genres are like comedy. There is a horror movie, and so on. And then I have one more file here, which is 12 show and tell USA temperatures. Okay, so this one is also a file where you have state, city, month, day, year, and average temperature. And the file is like CSV file. It's all comma separated. Okay.
Okay. Okay.
Now what we are going to do is go into Spark. Okay. So one thing I did, I placed these files on all of our servers. Now imagine if you had a NFS where HDFS, you have this file in HDFS, there is only one location you have, and then you have 6 nodes of Spark which can take that large file and process it. Okay.
Mm.
Now, because these are just CSV files and we want to give it to all workers, we just place this copy on all 6 nodes in the same location.
Okay.
All good? Okay.
Mm.
Now that we did that part, you remember when we want to interact with Scala, we started Scala. Same way, when we want to interact with Spark, we'll start Spark shell. So if you see which Spark shell, right? Just like SQL shell for interacting with Cassandra, here we have
Okay.
Spark shell. So we'll say Spark shell. Okay. So what we are doing with the Spark shell, as soon as you hit Spark shell, basically it is a small program. You are going to
Mm.
interact with the Spark. You connect to the Spark master and submit a
Mm.
job, and then that job will get distributed to its workers. Spark
Mm.
master will keep track of who is doing what, and then bring us the result into one place.
Yeah.
Okay?
Yes.
So it's highly distributed, very powerful analytics platform. It can do a lot of stuff. What we are going to use it as just to see how to interact with Spark right now, and we'll go into details later on. Okay. So what we'll do first, as soon as it starts, we'll try to understand the basic output it has printed on screen. You are using
Mm.
Spark shell to interact with Spark. You have connected to the
Mm.
Spark master. Okay. Let me
Mm. Mm.
explain how this goes. So we started Spark shell. Some warning message I would ignore. Spark is using
Mm.
log4j. So it is using these profile properties. So you can go modify that properties file if you need to set up your own custom logging. And then default logging level is at warning level. So all warnings will be recorded, and then all info messages will be ignored, or whatever that logging thing is. You can adjust the logging level using something, right?
Mm.
And then what I want you to more focus on is this. So if you want to interact with the Spark context, you can go to that website, like the IP address 4040 is the uh, place you can go,
Mm.
and it is telling you Spark context is available as SC, Spark session is available as Spark. And then it also tells you that it got connected to this particular master with this
Mm.
application ID. Okay. Let
Mm.
me explain what is, okay, before we explain that, okay, so what is this welcome to Spark version 301 using Scala 212.10, and you're using OpenJDK. This is the version of OpenJDK and some more things. And then you see this nice Scala REPL. you already worked with earlier. Now, remember, to run Spark, you don't need Scala pre-installed. The only thing you need is Spark, and it comes with its own Scala. Okay, done. Now, let's go back to looking at what is this SC and what is this Spark. Okay, now we are interacting with somebody called Spark. How do I say, hey, you know what, listen to me, do something? How do you call that Spark? So there are two ways to call it using Spark context. One is called Spark context. The other one is called Spark session. You can interact with Spark in both ways. You just have to call it SC or Spark. Okay.
Yeah.
Now we'll use that SC and Spark in a second. But what we'll do first is I want to go back to our master and refresh it. Now you should be able to see this application, which is Spark Shell. So you can see here it's a running application. It has 24 cores, this much memory per core, and it has whatever submission date, who is running it, which is the user and all that. You click on this, you can see inside on what it is doing. Like you can go to application GUI and then you can see more details about what it is actually doing inside. Okay.
Yeah.
Now, at this point of time, don't go too detail on this. Just understand that there is a UI and you can use it. Okay. I wouldn't go too much digging right now. What we will do more is in this shell here. Okay. You remember that Control L, nothing to do with Scala. It is a Linux command. It just clears the screen. Now here is what I want to do. Well, okay, I will call mf, which is movies file, equal to, you remember that SC I was talking about? SC is the, how do you talk to the Spark context, dot,
correct.
I'll say text file. Okay, so we have a text file. I want SC to read it. Okay, so here, remember, you can pass, okay, let's do one file name here. So I'm going to just copy paste something. And here is the file which has movies data. Okay.
Okay.
Now imagine you have the same text file in the S3 bucket. You're going to just point it to S3 bucket. If you have it on HDFS, you just point it to HDFS. This text file can be read from anywhere. Okay. So just sc.text file knows how to open it and process it. You don't have to do anything.
Okay.
All good?
Yeah. Yes.
Enter. Okay. So what I'm doing is I'm declaring a val which is immutable. What it does internally, it remember previously I was explaining, right? It creates MF in memory. It is the type of this, which is RDD, resilient set. Okay. It's a string type. It loaded this file. Okay. As map partitions RDD. You will read a little bit more about what is RDD and all. It's a small and how we interact with our partitions. Okay. Now what happened is that file became partitions in memory.
Okay.
Remember one thing, Spark has two things. Okay. One is you define and then you execute. So until you really ask for an action, it's not going to do anything. Right now you just declared. Okay. Let me give you an example. You go to a restaurant, you want to eat pizza. So you call the say for example, bearer, right?
Yeah.
So you called the bearer name is SC. Here it is Spark context. What you told the bearer is, okay, I want to eat pizza. I want light cheese. Half of the pizza should be tomato sauce. Half of the pizza should be jalapeno sauce. I want tomatoes on it. I want pineapple on it and put some jalapenos on it. Okay. And some green peppers on it. So you're telling him what you want, the order, right? And then he says, okay, do you want anything else? You don't want anything else. So he'll say, okay, go make the pizza now, right?
Yeah.
Until you tell him, go make the pizza, it's all declaration. You can sit there and tell him all day, you can declare, say, for example, I want this pizza, I want that biryani, you want this fried rice. You can keep on telling that for one day until you give him that action, which is like, okay, go bring it now, right?
Yeah.
He will not do anything. He'll just keep on recording your instruction.
Inputs. Yeah.
Okay. So Spark
Yes.
is same thing. It will collect all day. You can declare, open this file, open that file, open this file, open that file. It will keep on recording all that. Now, what is the action is, you say, okay, now tell me how many rows are in that particular file. Until you ask for a action, it is not going to open the file. It is not going to even check whether that file exists or not.
Okay.
See, Barer also, you told pizza, and when you say go make it, he'll go into the kitchen and check whether they have tomatoes or not. So he's not going to know whether tomatoes are there or not until he goes and checks, right? So now what
Yes.
happened? You say, okay, go make it. He's going to go inside and say, sorry, sir, we don't have tomatoes today.
Okay.
So it did not check whether this file exists or not. It's just a declaration it did so far. Good. Now what I'm going to do is I'll say mf dot, you remember the tab? Now what can you do with this RDD, right? I clicked on tab, immediately it prints a lot of stuff.
Yeah, correct.
Okay. So now what
Okay.
I'm going to
Okay.
do, I'll show you what actions are possible. I'll say count. Okay. Now what you can do, you can open close count method. Okay. Or you don't even write the brackets. You just give an enter key. See the power of Scala when it is implemented into a platform like Spark. What it is doing now is there is a huge file. Imagine it's a huge file, and it actually loaded all the rows into distributed partitions into 6 nodes into memory. And then when you give a count command, what it is doing is it is just going and counting how many entries are there.
Correct.
And it gave you a result. Okay.
Yes.
Again,
Yes.
we are following the REPL: read, evaluate, print, loop. That's all you're doing. You can do this all day sitting here. Okay. mf dot. Now I want to print like 3 records. You say take how many records? 3. Okay, what it does is it just goes and says, hey, guys, I'm distributing this job. Give me 3 records. And then master
Okay.
collect the result and print it as an array. Whatever first 3 results it is going to print. It is not in order, nothing. It's just a distributed database. Now Spark is a distributed RDD in memory. Okay. So you said take 3, it printed take 3. That's it. It doesn't care what order it is and all that. Now, you do remember some of the functions we were using earlier. When you say take 3, I don't want to print them as array. That array I want to process as if it is for each. Okay. And then take each of the record and print ln. Remember that you can take for each and print ln.
Correct.
Okay, there you go. Now what it did is
Yes.
it went into the RDD. It read the text file, right? It has
Correct.
distributed into the memory. Now in memory, it is taking 3 entries. Entry is a line, full line. For each of the line, for each of the elements in the array, for each line, print it. That's what it is doing here. You can actually do print, and then there is no enter keys in between. It will just print it as a long text string.
Okay.
Okay. So this is what we learned with our Scala. Now only thing is you're interacting with Spark. Okay. So what I'm going to do is I'm going to take this into the next level. Okay. You know how to count, but what I'm going to do is I want to apply some filters to it. So I don't want to see all the movies, but I want to see some specific type of movies. Okay. I'll say
Okay.
val HM horror movies. Okay.
Mm.
So we want to do MF. This is the movies file dot
Mm.
filter. Okay. There is a filter. So you can apply filter like this,
Okay.
right?
Uh-huh.
You
Mm.
see how I'm using tab to fill it.
Mm.
Now, whatever is the input dot, if it contains, okay, I'm looking for a string here, okay, and what is the string I'm looking for is I'm looking for horror. Remember, your data is case sensitive, so I'm looking
Mm.
for horror. Okay. Now you see what I'm doing here. Actually, I don't even have to declare this piece here. Okay, so I can say I
Mm.
want to MF filter
Mm.
whatever input you got,
Filter.
whether it is
Mm.
single line, several entries, whatever you got, each
Mm.
line, if it contains horror, what do you want to do with it? Let's say, for example, count.
Mm.
Okay. So all you're saying is look at the file in memory. It's already loaded into memory. Filter the records and show me the count. Okay. It says out of whatever 1600 records we saw earlier, 1659 movies, it is telling me 57 of them are horror movies.
Correct.
Cool. Now,
Correct.
you
Yes.
know, whatever we learned so far, you can go further. Like, say, for example, you can say MF filter contains horror, print 3. So take 3, and then for each, see how I'm combining whatever we learned so far.
Mm. Yes.
So imagine
Yes.
what we did in 2 lines of code. First line was
Mm.
this, where we declared the file. This is the first line of code, which is
Correct.
opening the file, distributing it on the
Mm.
network.
Mm.
It has made several hundred partitions, small ones. And then
Okay.
you're writing the second line of code here, which is read that file, do a filter, take 3,
Yes.
for each of
Yes.
them, print it.
Printed.
Imagine doing this in your PL SQL, SQL Plus, or C
Lots of
Sharp.
code. You need
Lot
to
of code. Lot
run
of code.
here like
Not a
single
joke at
line.
all. That's what it will
Correct.
do. Okay.
Mm. Yeah.
Okay. That was fun showing you just how much we can do with this, what we are learning. Right?
Yeah.
Let's take it
Correct.
to the
Correct. Yes.
next level. Okay.
Mm. Mm.
So what I want to do is I want to extract. There was a year column. Okay. So in the in the file there is a year column, and you want to know how
Okay.
many movies released in each year. So you're doing
Mm.
essentially what you're doing is select year comma count from table
Mm.
by year. Now what I'm going to
Mm.
do, so first of all, val, okay,
Mm.
movie year,
Mm.
my is movie years. Okay, let me just put it as my s, mys, movie years equal to,
Mm.
you already declared your mf, already it is in memory. Okay,
Mm. Mm.
now
Yes.
you remember map reduce, which was from Hadoop. So you're
Mm.
mapping and reducing. There are two different actions you're going to do. Okay. So what is that you're
Okay.
mapping? This is very important to understand, that underscore will repeat again and again and again all year long. Okay.
Okay. Okay.
So map. Now what you're doing is you're taking each line you're getting as an input. So that is your line.
Okay. Mm.
Split it, because you know it's a comma separated, but separated by semicolon here. Okay. So
Okay.
your delimiter is semicolon. Sorry, I must have said it's a comma separated, but delimiter is semicolon. Okay.
Mm.
First thing you are taking is map, underscore is your line, split it. Every single value inside that will be split using semicolon. Okay.
Okay.
Now
Mm.
map. So imagine you have a line and the index numbers go from 0, 0, 1, 2, 3, 4, and so on, right? I'm saying pick up that 0th column.
Okay.
Okay, the first
Hmm.
column.
Hmm.
Okay, so let me do one thing. Instead of confusing you this way, I'm going to just go here and then go to software, cat 12, no, I'll say head 3, cat 12 movies, right? .csv. You see the first column is the year,
Correct.
1990, 1991, 83. Okay, so what I
Hmm.
want to do is from the line, when you split it with semicolon, take the first entry, which is 0, 0th column, convert it to int. Okay,
Okay.
so when I do that, what I'm saying is pick up all the years from the file. Imagine if you had years for every single entry. Okay,
Hmm.
then what
Hmm.
I'm going to do, I want to say mys, okay, take 5,
Hmm.
3, and then you remember your for each.
You're printing.
Okay,
Yeah. Hmm.
now I am expecting error for this. You know why? So far we were
Hmm.
declaring. Now actually you have executed action and it is printing the output. Okay, so there is no error. That is good.
Hmm.
But I was expecting a different error. Anyway, imagine if you had a heading line in your file, which is like year, movie name, and all. That will be a text. So when you extract the first column and convert it to int, there is a possibility that you will get error.
Okay.
Here we were expecting error. We did not get it. That's fine. But
Hmm.
you see the 3 rows which came and the extracted year. Okay.
Okay.
So your MYS now is a RDD of integers, and it is all map partition RDDs distributed across your cluster.
Okay.
Okay. That's all we
Hmm.
need to know. Now what we are
Hmm.
trying to do is actually group by, right?
Hmm.
So how do you do the group by? Okay. So what I'm going to do
Okay.
is val movies per year. Okay. So you see that MYS already has the years in it. It
Yeah.
has only years, nothing else in them. So in this, I'm going to map. Okay. You see the underscore is the year column, right? The first column.
Yes.
I want to make it a key value pair. So you see this underscore and then
Hmm.
value is 1. Key is the year itself.
Hmm.
Okay. Now I'm going to close these two brackets. So what I'm doing is I'm mapping every year. It will become every year, then a value
Hmm.
is 1. Okay.
Okay.
Then reduce by key. Key is your movie year. That is what I'm doing.
Okay.
When you say reduce by key is the movie, right? When you do a
Hmm.
reduce, you're saying
Hmm.
underscore plus underscore. Okay. So whatever value you have, keep adding it to the previous value. Okay.
Okay. Okay.
Let me explain it in the text format. So what I'm trying to do here, your MYS contains this. So you have 1990, 1990, 1998, 1991, 1997, something like that. Okay.
Okay. Okay.
Now what we wrote here with this code, right? I want to explain how it is written. So you see this map underscore. Underscore is nothing but each of these years. Okay. So
Okay.
the first map, if I explain this particular piece, what we are doing with this is we are generating tuples which will look like this. So for example, you take these and paste them here, right? And then imagine it will look like bracket, bracket, bracket. You're making a key value pairs. Okay. So something like this.
Hmm.
So it is going to generate key value pairs. Step 1.
Okay.
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 Then what you're doing, so imagine the power of this, Anil. If you understand this piece, right? If you have 5 rows or you have 10 million rows, you are writing only one line code and it is able to run the whole thing in a big cluster. Okay.
Correct.
So what you're doing is step 1, when you do this map, take each of the year and also make it a key value pair. You're giving one there. That's why it is all one. And then you're saying, take that key and reduce that key, okay, by the value. So what it will do exactly is, so the first thing it will do, first it will take one row, right? So
Yeah.
key is 1990. What is the value? 1. Okay.
Yeah.
Then what it will do, it will iterate. Let's say second time when it takes the second line. Look at this line, right? Again, 1990. What did you say? If it is 1990, already value is 1. You want to add the next value to it.
Correct.
Okay. Then what it is doing
Yeah.
is it is doing 1990 plus,
Mm-hmm.
sorry, 1990 value is 2.
Uh-huh.
Okay. Then
Okay.
go to pick up the next line. So is it 1990? No. So iteration goes back to first line. It says 1998
Mm-hmm.
is value 1. Then go to the next row. Oh, this one is a different one. So 1991. Okay, so while we were talking, right, I added one more entry here, one more 1990 later on, just to show you how it will iterate. Okay, so we
Mm-hmm.
were working with 1998. It took that row, and then
Okay.
next value is 1991. So then
Mm.
1997 comes, right?
Okay.
Let me do one thing.
Yes.
We were looking at this, okay, 1997, and it is going to leave 1. Then it sees this 1990. You see, it was already having this value 1990 here. So it will
Mm.
bring it down, right?
Mm.
What is the
Mm.
1990 value right now? It is 2. Okay.
Okay. Okay.
But now there is a next entry here. So it is going to take this, okay, and move it, right?
Mm.
Now what it will do, it will make it 2 plus 1, right? Already existing value plus the next value
Okay.
equals, it will say 1990, comma 3.
Mm.
Okay.
Mm.
Now, are there any other rows? I think it is done with the iterations, right?
Correct.
Now,
Done.
what is your final iteration? So this is your final result wise. Okay. So the
Mm-hmm.
master receives this result from all the workers, and this is your final list. So you see what it did? Okay, let me explain. It took some value, you told it to map to a key
Mm.
value,
Mm.
and then you told take those keys and sum up the values, reduce by key,
Okay. Mm.
and then produce this output, which is your group by output. What you're doing is take all the years,
Mm.
group by year, tell me the sum of these entries.
Okay.
All good? So that is
Yeah.
one line code we wrote here. Okay. Now
Mm-hmm.
imagine what it does in the background. It goes and tells all its workers, hey guys, you go run around, give me the key value pairs, and then reduce it by key. So it is actually
Okay.
that group by. Okay. Now,
Mm.
only thing it did here, what you see is it actually generated another RDD, which has key value int, and then it got stored into the movies per year. Okay. What I want to do, I want to
Mm.
say movies per year dot
Mm.
take
Mm.
how many you want. Let's say, let's take 50 rows. Okay. And then you want for each print ln. So basically 4 lines of code. You declared where is your file. You told how to split and extract one column. Then you told what to do with those columns by map and reduce. And then now you're
Mm.
printing the result. Okay.
Okay.
See, until you did the take, it did not do anything. It was taking instructions. And when you did a take, it is actually action. That's why it took some time before printing it. You see what it did? So it took each year, telling
Correct.
you how many movies are there released in that year. And again, it is not in order. It is not sorted order. It is just giving you output because you never told it to sort it. You can actually ask for sort by key, something like that.
Okay.
But what do you see the power wise? What you did here, if you really observe, right?
Yeah.
So you did a couple of things here. Let me put this in our code window here. So in the explanation, this is how you open the file. Okay. And then you split the file. So whatever content is there, you use the semicolon to split and extracted the first column. Then you took the first column, made it key value pairs and reduced by key. And then you printed them. Okay.
Okay.
Now there are two ways to do this, right? One is you can say take 50, take number of rows, or you can do collect. Collect is you're not limiting by 50, you're just saying collect everything as a result and show me the result. Okay? So it is just going to collect everything and show you the result. Okay. So if you want to understand the power of what we did with these 5 lines of code, okay, remove this. What you did with this is these 4 lines of code, you can run it on million things, million entries, or you can run it on 5 rows. Doesn't matter. Spark is able to handle that. Okay. Let me show you the power, right? So for what you learned, you can actually read the file. Okay. Map it by doing this map. You're going to split map. Okay. In that map, you're going to reduce. You convert it to a long line like this. Okay. So let me just put it in view. Let me see if we can do word wrap. Okay. Reduce it and then collect it and then print everything. So one line code. Okay. So let me explain. SE is the Spark context text file. You're telling where is your source. Okay. Take that and map and split it. Split the each row. Once you got the row, because you already split it becomes arrays, take the first entry, convert it to int, then map it as key value pair, then reduce it by key, then collect the result, and then print it. So imagine writing this one line code can go on million row file and run it.
Very powerful, right?
Extremely powerful. Okay. So imagine you had a function like instead of for each print, what you'll do is collect, save it back to a file. Something like this.
Okay.
Correct? It can do that. That's why I'm saying there is some equivalent function or method you can call.
Okay.
And you don't even look at the code. You just run this one line, it saves the file. Now it can take 3 hours to generate the file because it's a long, large job. It can take time. But what it can do is this amazing stuff. So we did one part. Let's move a little bit forward with this. So I want to show you a little bit more powerful stuff. Okay. So we did some mapping, some things, but we'll do a little bit more to understand how this thing can work. So what I'm going to do is movies file, I'm declaring where it is. In that movies file, map and split we already saw. Take each column by separating them by semicolon. Okay. Instead of taking the first column, I'm taking the second column. Okay. Now that second column is the movie runtime. How many minutes does it run? So map that given X, whatever is the length. If at all that length is greater than 0, if the given length is greater than 0, then return X, otherwise return 0. So
Written 0.
yeah,
Okay.
you see this one is a decode function. Actually, if you look at it, it is like a decode function in Oracle, or it is also called immediate if, meaning you're writing your if condition in one line. You're saying, check this condition. If at all it is greater than 0, return how much minutes it is running. If it is less than 0, or you don't have that value, basically there is nothing written inside that particular length column, then just return 0, meaning I don't know how many minutes it runs. Imagine we don't know the movie runtime. Okay.
Okay.
Then whatever is resulting output, then map it to an integer. Take the file, split it by semicolon, because that's the it's a semicolon separated file. Pick up the second column in each row. If that second column, if it has any length, like what is the string length of that second column? If it is greater than 0, that means it exists. Then give me whatever is existing. If length is not there, meaning we found that length is 0, then just return 0. Then we don't know what is the length, but we just going to consider it as 0. So essentially you're saying E is null. If it is null, give me 0, NVL function.
Yes.
Okay. Then whatever is resulting output, give me the integer output.
Correct.
Okay. Now what we are trying to do here is we want to figure out how many movies run for more than 100 minutes. Okay. So let me show you what happens when we want to run this thing. Let's say, for example, take 5. Okay. You want to take 5 rows. So first run this code just to see what it results in. So, Control L, paste it, declaring and actually doing an action. So you got the runtime for the movies. Okay. Now what you want to do is, I want to figure out how many movies run for longer than 100 minutes. You see that 94 will be gone.
Will get excluded. Yeah.
Correct. So what we'll do, we'll add one more line. Instead of take there, what we'll do is we'll write something like this. So we'll not take this. Instead, we'll say how many movies run for more than 100 minutes. So what I'm saying is we have all the 2 movie times, right? Now take that each value, whatever you got from that length, right? If X is greater than 100, give me 1.
Greater than 100.
If runtime is greater than 100, give me 1. Otherwise, give me 0 and add them up, right? So if it was greater than 1, it will count it as 1 entry. Greater than 100, it will count it as 1. If it was 94, it will count it as 0. Just add up all those values. That will tell you how many movies are running more than 100 minutes.
Now what is the sum is doing now here?
Sum is adding up all the... This is the power here. Okay. So see this map and reduce. Okay. Let's take our example of what we got here, right? The array. We'll take that. Okay. So this is the array. Okay. So now tell me 111, is it greater than 100?
Correct.
Then it will result in 1.
Yeah.
Okay. 113, is it greater than 100?
Correct.
Result in 1. No, don't say correct. Tell me whether it is greater or not.
Yeah.
Yes or no. So 104, is it greater than 100?
Yeah, it is greater.
Okay. Then you have 122. greater than 100?
Yeah, it is also greater.
Okay. 94, is it greater than 100?
No, here it is not greater.
0.
So
Then it will
0.
return in 0, right?
Mm.
Okay. Now on this column here, the column which resulted, if you run a sum of this, what do you get? So
You get 4.
1 plus 1 plus 1 plus 1 plus 0.
4.
4. So what does that mean is, out of 5 movies you
Uh,
evaluated,
uh-huh.
only 4
And
movies run longer than 100 minutes.
okay, got it.
This is mix of statistics, map reduce in Hadoop, and lot of mathematics, lot of data analysis. Data scientists do this work. But you see the power
Yeah.
of Scala and Spark together. Okay. Now, what I want to do is I want to display this output. Okay. Dot collect. So what I'm going to do is just paste this whole thing in one shot. Okay. I'm going to do this and then paste. You see, declare, 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 and actually run. There is no collect. That's why it is giving you error, because it already is a val, which is 839 movies out of 1600 movies run for greater than 100 minutes. But here is the power of Scala again. Okay. So I don't need to capture anything. I'm just going to do map, split, map, convert it to integer. Okay. Then I'm going to say again map, convert it to sum, and then I'm going to say take. Because sum is going to result in only one row, it is going to take and display it. Okay. One line code, it is going to do the whole thing. So I'm just going to do sum, not take. Okay, so let it run, but this is the right code. There you go. That is the result.
839.
800. Okay, so what does it mean is, so let me show you. We know that we can count how many rows are there. Okay, so let me clear this screen. So this is telling you how many movies are there. Okay.
Yes.
This is telling you how many movies out of 1659 movies, how many run for longer than 100 minutes. I want to show you one small thing just to show you the power of this. Okay. Now the movies file only contains 1600 entries. Okay.
Yeah, correct.
But imagine this file, we just want to count how many rows are there, because who cares about running this data 1600 rows? No big deal, right? If you run something on this large file, that will be fun.
Oh, you have one more CSV file.
Yeah, you see this USA temperatures.
Correct.
It has 1 million rows.
Yeah, exactly 1 million.
That will be fun, right? Whatever we did so far is a very small file. You can do it in a text editor. Now I have another file here. If you look at the header of this file, this is also a CSV file. Basically what it contains is, it has a header row on the top. You see this one. What it tells you is there is a state, city, month, day, year, and then average temperature in that location. So if you look at this, so for example, Alabama State, Brigham City, on January 1st of 2000, temperature was 59 degrees Fahrenheit.
Correct.
So this file is very large. Like if you look at WC minus L, let's say how many entries are there, you have like 1 million entries in here. Okay.
Correct.
Now, what is the idea is we are going to use Spark to do some analytics on this particular file. This is a large file. We'll go
Okay.
back into Spark and do something.
Mm.
So you can see here, I have my Spark shell running. I'm connected to a master running on Doom 3 server. And then I'm going to just clear the screen. So first thing I want to do is to get that particular file read into memory. Okay. So using this command, what we are doing with this is I'm say for example sc dot, which is spark context dot text file. I'm saying read this text file and the path of the file. Now
Correct.
what is important to understand here is this file, because Spark has 6 executors and then it has a master. So Spark, all the executors are on the 6 nodes. They all need to see this file. That means they all need to have this file locally available. Now, if at all you have the file on HDFS, let's say, right? Then you have file in the central location and all nodes will be able to see that HDFS location. Or you can keep it in Amazon S3 and all nodes will see the S3. Okay, so then you don't have multiple copies, but it's single copy and then all nodes will be able to see it. For our case, nobody really takes the CSV file and does this analysis. It's just for learning purpose. We have to keep this CSV in the same location on all nodes where your Spark is running. Okay.
Okay. Mm-hmm.
Now, when I give an enter key, what it does is Spark itself is going to just declare what is required to declare this. So what it does is it creates an RDD, which is a resilient distributed data set, which is in memory of strings, RDD of strings. Now, what it basically does is always remember Spark has 2 things we can do with Spark. One is transformation, which is like a declaration, like say, okay, take this file, do a filter, do a map, do a reduce, okay, or do uppercase, lowercase, conversions. All that stuff is called transformations.
Okay.
Now you can sit there and give like 1,000 commands, which are all transformations, and Spark will keep on recording the transformation. It is not going to do anything, meaning it doesn't go check if the file exists, how many rows are there in the file, or does it fit into memory. It doesn't do any of that. But
Correct.
when you execute an action, it actually goes and reads the file and does whatever steps you want it to do. Okay.
Okay. Okay.
So let's see what will be a action. Let's say, for example, this USA temps is in memory now. It's RDD. Obviously, it did not do anything. As I said, it did not even load the file into memory or anything. You can do USA temps tab. You type USA and tab will fill the temps. You can put a dot and then another tab. It shows all the possible things you can do with this RDD. Okay.
Okay.
Now, all these things you can do with the RDD, you can see here there is a count. Okay.
Correct.
So what
Yeah.
you can do, USA temps dot count, and then count has like the action which starts with count has 4 or 5 options here. You can see you can do count approx, distinct, async, and so on, so on. Okay. What I'm going to do is just count. Okay. Now, let it run. It has like, it will take your command and convert it into stages and run the count and give you the output. So that's how Spark does. Like, it will contact its executors and say, hey, why don't you take this piece and do the count and then do something else and so on. Okay.
Okay. Okay.
Now, as I explained, the first command we ran, this was the transformation and this was the action. There are 2 things here. Okay. Now, as I said, when you do transformations all day, like you can say, okay, take this file, filter, do something and do something else and so on. All those transformations are not executed until until an action is executed. So action is the last thing. Okay. Now, let's see what is in memory right now. If you say, for example, what Spark does right now is it takes the text file, loads it into the memory, counts how many rows are there. Each line became a row and how many rows are there, right? Does the count and then releases that memory. So basically it marks saying, okay, this memory is no longer required, right? You know that this is in background, it is running JVM. So that whenever GC comes up and it sees this memory, it will clean up. Doesn't require this object anymore.
Okay.
Okay, whatever is in memory. So remember, Spark will load and do whatever you need to do as soon as you hit that action.
Correct.
But as soon as that action is complete, whatever it did in memory is all cleaned.
Correct.
Okay, gone.
Yeah. Yeah.
So at certain point, you can do caching. We are not talking about that yet, but you always remember, once you hit the action, first action, it will clean up the whole thing. All the job is done. It will remove it from memory again. So if we have to run another action now, let's say, for example, USA temps, right? Dot, let's say count approx distinct. I don't know what it does. I'm just going to run it. So what will happen when you run that? Imagine there is no error. If that was a correct statement, let's say, for example, we'll do the count again, right?
Yeah.
Like this. So what happens is this time when I ran the count, it is not running in memory. It is starting to load the file again and do all the steps again.
Okay.
Okay. Remember that action will make you go through all the execution again.
Correct.
Okay.
Yes.
And I'm not talking about caching at this point. We'll talk about it later. Okay. Now, let's clear screen, and what we'll do, instead of US attempts count, right? I want to see some data. So let's say, for example, take five rows. Okay. For each line, you already saw this thing, println. What you want to do is take five, any five, random. I don't care the order or anything. Take five. Okay. For each of the line or whatever entry you got for each of them, println, what is that you want to print? Whatever you got. So understand that underscore we discussed already. Whatever is coming in for this operation, do whatever I'm asking you to do, like println here. Okay. So I'm giving an enter key. Let's see what happens. So this is the action. Okay. Take is an action. So it is going to get to fetch 5 rows and display them. As I said, I don't care about the order or anything, just print them. So remember, in Scala, we want to write less code. So you don't even have to write this brackets underscore code there. Okay. So these two will produce exactly same output. But only thing you have to remember is USA temps was not in memory. Take is action. So it goes and fetches that whole data again. And what we'll do now is we'll look at some more transformations and actions. What we'll do, as Scala is built, like, you can keep on writing methods on the same object. You can write it something like this. Okay, you're actually chaining the whole thing. So what you want to do is take the USA temps. What I interested in is in Boston city. So I'm going to apply a filter operation on that transformation.
Okay.
Whatever came in, which is a single line which comes in, convert that to a lowercase. So you see this lowercase. Okay.
Yeah.
Converted text, whatever got converted to lowercase, dot contains, meaning if that line contains this string here, which is comma Boston comma. Okay. You see the format here is city, state, city, month, but they're all separated with commas. So Boston can exist somewhere else in the state also. What I want to see is if there is a comma, Boston comma. If that string exists, set up. Okay. Now take that and apply a map transformation on that.
Okay.
Okay. So what I did is, if I did a filter here with this whole thing, I did a filter. And how the filter works, I said, take each line, convert it to lowercase. If that converted text contains Boston, then go to the next operation. Next operation is a transformation again. So I'm going to take that and apply a map transformation. Okay. Now what I have written here is inside what I'm saying, whatever has come in, right? Again, it has a line or a row, split it using commas because it's a comma separated. I just want to split them. Okay.
Okay.
Now, what happens when you do this map? Okay, let's see. What is the next operation? I'm doing a action. I don't want to do this right now because I want to see what will be the output of this, right? So when you run that, you can see it created a RDD of array of strings. So you see array of strings is the primitive data type in Java. Whereas the RDD is actual Sparks object. Okay.
Okay.
So what it did here is when you ran that map and filter and map. So you applied a filter, you got only Boston strings, and then you applied a split. Okay. Now split actually made that whole string into smaller pieces, which became an array of strings. All good. Now instead of just seeing what is the data type, I would like to do a take 5. Okay. Now, remember one thing, if you actually do this, right, because you already have this RDD in declaration, you can do a res5 dot take, let's say 10.
Yeah.
Okay.
Yes.
Now it is running and then everything will be gone from memory. Remember that again. As soon as you execute the action, entire previous steps will be done. It will
Correct.
mark it as done. Okay.
Yeah. Yeah.
So
Yes. Yes.
either you can do it like I was showing you, or you can do it in one line like this. Okay. While that is executing, if you look at this output, the previous output, what we got. So we got Massachusetts, Boston, 1st of January, 1995. This was the temperature. That whole thing became an array. Okay.
Okay.
Then you got several arrays like that, which were resulting in array of strings. Okay. Now, when you actually take out the RDD itself from picture, it becomes primitive data types. As long as you have it in RDD, you have the Spark power.
Okay.
So remember, this transformation is very powerful. Okay. In Java, you might have to write like 30, 40 lines of code, or even little bit less, but it is a large amount of code you have to write to get that. Okay.
Okay.
Now, so what is our purpose here was, I wanted to take Boston and get the temperatures of Boston, but I just did a take 5, which is only, I just want 5 rows. Now let's take this further, a little bit of more discussion on this. I'm going to run this code. Okay. Let's understand what this code does.
Okay.
This portion you already know. I'm just converting it to lowercase, contains Boston, and then map and split. Until this portion you already saw.
Yes.
Okay. Now we have to understand what this is will do. Okay.
Okay.
So let's take the same code, put it on Notepad++. So until first map you already know, and then distinct and collect look like very known things. All we need to know is this. Okay. So for example, in your text file, so if you imagine this is your first column, let's say, right? Element, second element, third element, fourth element, fifth element, meaning your index started at 0, 1, 2, 3, 4, 5. Okay. That's how it is going. So if you look at this as the second and third, fourth, fifth, and this is fifth. So is that all good?
Yeah.
Elements wise. So now you see your index starts at 0. You are saying map, whatever is coming in, give me the fourth element.
Okay.
starting with 0 index.
Mm.
So what is the fourth element? Year is the fourth element. If you see 1999 is the fourth element there. Correct? This
Yes.
portion,
Yes. Yes.
highlighted one. Okay.
Yeah.
Then convert it to integer. Because so far it is handling it as strings. I want to convert it to integer.
Okay.
Then apply distinct on it, meaning it has so much data from Boston itself. You know what we can do? We want to figure out how many Boston entries are there, let's say, that we did not do so far. So I'm just going to do you just going to filter and count, right? You don't even have to map, correct?
Correct. Yeah.
Okay. So out of 1 million, 1.1 million entries, how many are Boston entries? We'll see. 7,600 of them are Boston entries. Okay. What I'm doing with this particular operation is I want to split, then I want to map the fourth element, convert it to integer, distinct, and collect. Collect is again an action. What you're doing with that collect is you want to show the result. Okay. So driver is the Spark job. Okay. Then driver sends the job, splits the job into stages and sends it to the smaller workers, which are like executors.
Okay.
Then when you apply a collect on that, so it was doing all the transformations, everything at distributed level. When you do a collect, it is collecting the result from all the workers and show them on the screen or return it to the program, right?
Yeah. Yes.
Okay, so what we did with this particular operation here, if you see, it returned a array of integers because you converted it to int in between. It gave you an array of integers. If you see what it actually tried to do inside, if you notice, it is telling you I have data for these many years.
Correct.
Okay, all good.
Yeah.
So
Yes.
what
Yes.
we were trying to do with this particular query was I want to know how many years of data do you have in this file. Cool. So we
Yeah. Yes.
understood
Yes.
each portion of transformation and then action.
Yeah.
Now, I want to take this further. So for example, you know that there are so many years of data, right? So let me just keep this for our own understanding. I don't want all the years, okay? I want specific years. I would like to filter the data, okay? So again, I'm going to build based on the things we learned so far. So you see this one, you understand this line highlighted line, which we're collecting only Boston data, splitting them using comma separation. Then I want to apply a filter operation, which you saw, whatever is coming in, take the fourth element, convert it to integer. And then you're applying a where clause, which is in between 2010 and 2013. You see this?
Correct.
Okay. So you already
Yeah.
got Boston. You already got the splitted data into array format. Now you're applying another filter which says,
Correct.
okay, I don't need all the data. Just give me these years, 2010 to 2013. Then again, you know the map again, right? Apply another map on top of this, which is take only the year and then
Correct.
distinct and collect. Okay.
Yeah.
So
Yes.
far, whatever you saw, I'm just building upon that example. Okay.
Correct.
So you see how you're writing a single line and Spark has to do 1,000-line code in the background. So it's very easy to see how much work is Spark doing.
Correct.
Okay, so now let me take this and paste it here. So now you see, you said, okay, give me only 2010, 2011, 2012, 2013 data. Now, instead of doing distinct collect, I can also do a count here at this level to see how many rows are there for these 4 years. Out of 7,000 rows, you remember, Boston has 7,000 rows. I'm saying now 1,400 rows for those 4 years of data.
Okay.
Okay. So just to show you different things here. Okay. So far, what we discussed was let's put that into a small context here. Like I'm going to just remove all this. We'll talk about two or three things which are theory. Okay. When Spark 1 started, they said we handle all the data using RDDs. Okay. Resilient distributed data set. What does that mean is you distribute all the data in memory using RDDs. And whenever you're telling me, okay, take this data, do this transformation, do another transformation, on top of that apply a map transformation. So let me take an example of what we did just recently. If you take this is your source. And then you did a first transformation here with filter. Okay.
Yeah.
You did a map. Then you did a filter. Okay. Then you applied another filter, upper limit filter, lower limit filter, or reverse, vice versa. Okay. Then you did a map to take only the year. Then you did a distinct. That's also a transformation. So this is your source. All these are transformations. And then you did a collect, which is action.
Okay.
So whatever you did here, right? You're telling Spark to do one thing at a time. That is called DAG. So what it does in the background is whatever you're telling it to do, that particular command, let's say, for example, whatever input you're giving, that's a program you're writing, right? That creates a directed acyclic graph, DAG.
Okay.
So what it means is the instruction set you're passing to Spark. Inside Spark, we call it as DAG.
Okay.
DAG is the list of operations you want to do. RDD is the data in memory. RDDs are not typed, meaning so it basically tries to know whether it is an integer or a string based on whatever Spark sees. Okay, so you're not declaring any schema for that. Meaning you're not saying I have a city as string, month as int, day as int, average temperature as a floating point number. Right? You're not saying that.
Yeah.
Spark itself is trying to infer and understand what kind of data you have. Okay. So in Spark 2.0 or so, what they did is, RDDs are very basic way to work with it. It's not intelligent enough. Let's introduce something called DataFrames. So DataFrames, what they did is they created a new API called DataFrame API. Now, instead of taking your data in a raw format, load it into RDD, you use DataFrame APIs. What we will do for you is we will take the RDD as the data, and we will also bind schema. You are going to declare a schema. Okay. We are going to bind these two together. Now we have a data frame. Instead of directly working on RDDs, you work with data frames.
Okay.
Advantage is now every time you ask something, right, I exactly know what is the schema for that.
Okay.
Because if you think of our real RDBMS, right? When you do a create table command, you are actually specifying the metadata schema.
Correct.
And when you're doing insert into, you're actually providing the data. Okay. So RDBMS exactly knows what data should be stored in which column. So far with RDDs, with Spark, we were not doing that. We were just randomly giving it data and it was trying to figure out what is the schema.
Okay.
What we are trying to do here with DataFrame is exactly same thing. We are going to first declare the schema saying this is what my data looks like. And then we are going to provide the data in RDD. Then for us, Spark contains these two things for DataFrame. We are going to just use the DataFrame API. Okay. Now this is up to Spark 2.0, right?
Okay.
Somewhere in between, they said, you know what? DataFrames also are not behaving like we want. We would like to introduce something called Datasets. Okay. So this is a new API, okay, on top of DataFrames.
DataFrames.
But
Okay.
for now, you know, RDD is DataFrames, datasets, and DAG is nothing but the instructions we provided to Spark.
Okay.
Okay. Now, what we will do so far, whatever we have been doing with all these maps and transformations and all, right? We were actually doing, we were actually using Spark as if it is RDD, meaning Spark version 1. So what I would like to introduce is DataFrames. I would like to move you to the next level. We'll talk about DataFrames. Okay. So we'll get rid of this whole thing. Actually, we'll keep all this here. Okay. And then we'll start looking at new examples.
Okay.
Now what I'm going to do is, I'm going to take, again, we'll clear the screen. We are going to continue to use the same file. Okay. But you see this? I'm declaring a case class. Now you will see a pinch of Java there. So what we are doing is we are declaring a case class. It's a class. I'm calling it as CLS temps. I'm declaring state string, city string. You see the format of the file? Same thing I'm declaring here.
Okay.
So this is your schema. All good? Okay.
Okay.
Next step, you also saw this command before. I'm just declaring a RDD by using the Spark context text file, read this text file into USA temps.
Okay.
That also you already know. It's RDD.
Yeah.
And you
This is
same thing. Nothing new. Okay.
Yeah. Okay.
Then I'm going to run this command, but before running it, I want to actually explain. Okay. So see the USA temps, you declared it earlier. I'm going to do a filter of take only Boston. And then again, applying a filter here, map transformation. I'm converting everything from comma separated to individual elements.
Okay.
Okay. Now here is a small disturbance in our code. You see that underscore, so far I was saying whatever is coming in, right?
Correct.
Instead of calling it as whatever is coming in as underscore, I'm now calling it as T. I'll say temperature or some T, whatever is coming in. I can call it X, I can call it Y, doesn't matter. Okay.
Okay. Okay.
But here I'm calling it as T, whatever is coming in. I'm going to map and apply a class on top of it. You remember the class we declared? We're saying I'm applying class. Okay. Now T contains multiple elements. We saw the distribution, right? You saw 0th element, first element, second element, and so on. Now I'm saying T0, T1, T2, but when it comes to T2 is actually let me do one thing, just for our understanding sake, it's easier if we type that again here. Okay, so we'll take one row and then put it on the notepad and we'll number the elements. It starts with 0. Okay, let me ignore the comma itself. 1, and then you have 2, 3, 4, and 5. Okay, all good?
Okay, yeah.
Yeah, so easy, right? T0 is the state, T1 is the city.
Yeah.
So go on with wherever you think is the right place, I'm just converting it to integer.
Int, yes.
And then you see the T5 is the actual temperature, I'm converting it to double.
Correct.
All good? So far, so good? Okay.
Yes. Yeah.
Now what I'm doing with this particular transformation, right? I'm taking the Boston, I'm splitting them and applying the actual data types using this CLS temps as the class which was declared earlier.
Okay.
And then storing this whole transformed RDD into Boston temps RDD.
Okay.
Okay. So now if you have this whole thing and run it, so what it is going to do in memory, it will create another RDD.
Okay.
So far you have USA temps. Now you have Boston temps, Boston temperatures. So you see again, this is a RDD.
RDD.
Okay.
Yeah. Hmm.
Now, what I want you to understand here, one thing, you see this file we were reading earlier. It took the file
Correct.
and
Mhm.
created a map partitions RDD. And it created, you see these brackets here, which I did not explain you earlier. I want you to notice what it did internally is it did some math and said, you know what, I'm going to take this whole file and convert it into 27 partitions. I did
Okay.
not say you convert it to 27 partitions,
Mhm.
but it did some math.
Okay.
Okay.
Yeah.
Now, you are saying now you want to take this filters, operations, all that, take the original data, convert it to Boston Temps.
Hmm.
It took that given data, it created a map partitions RDD of how many partitions?
30.
Yeah. It did the math and it did something in the background and applied it. Okay.
Mm-hmm.
Now, what it created, you remember this was the RDD of strings,
Mm-hmm.
but this is a RDD of
Class temps.
class, the class you declared earlier here.
Okay.
Where did we
Yes.
apply that class? Inside here.
Inside the map condition. Yes.
Okay. So all good. We declared a schema.
Yeah.
We loaded our data as RDDs. For that RDD, I applied the class. So
Yes.
we actually joined the schema plus RDD.
Correct.
Okay. Now, what I'm doing now is I'm going to use this command to convert it to DataFrame.
Okay.
So far, we just applied the schema to RDD. Now I'm going to convert it to actual DataFrame in Spark.
Okay.
Okay. So this is how Spark 2.0 DataFrame API looked like. So it is doing something. Also remember one thing is it has when this DataFrame API comes, somewhere in between you will see something called Hive, because this was written keeping Hadoop in mind. Hive was the way they ran SQL queries. Okay. Now, introducing one more topic, you always want to check out this particular package, what it is doing. All written in smaller case. You see what it does is, where is this API loaded from? It is coming from org, Apache, Spark, RDD API.
Okay.
That is the package. And then inside that, there is a RDD object. And inside that is a whatever is the object type. Okay. Same way, when you converted the existing RDD to a data frame, it is using Apache Spark SQL package. Created a data frame. Here you don't have data frame of this type. See, it's just a data frame. But if you look at its output, right, it's no longer RDD. You see, it actually applied that state, city, string, four more fields and all. Okay. Okay. Now imagine your RDBMS is in memory now. Imagine that. Okay. Okay. Yeah. Now what I'm going to do, this is another small quirks here for the original data frame API. I'm taking the data frame we declared in the previous step. We're saying this is the data frame. Create or replace a temporary view and call it as BT. So from now onwards, I'm not going to call it as Boston Temps DF. Instead, I'll just call it as BT. Okay. Okay. So a temporary view I created. Now, once you do this, right? Now onwards in your memory, you have a BT. So what I can do now, because I'm already having a data frame, I can run Spark SQL on that. Okay. So you see what I'm doing, spark.sql, select star from BT. This we already know. We should be happy now. RDBMS guys. Correct. Okay. So now what we did is, whatever was the loading memory, all that thing, we overcome that. We are just directly jumping into spark.sql. I want to run a select statement. Okay. When you run only that portion of it, it will return another data frame. Instead, what I want to do is take 3 and print for each line println. That we already know from our previous examples. Okay. Okay. So let's run this. Okay. Now, what you can do is your RDDs, API will work, DataFrame API will work.
Okay.
Looks like this now. Cool. Now you can also do one more thing here is called show 3. Okay, because I want to show you a difference between these two.
Okay.
I'm running a show 3.
Mm.
There are two APIs. And again, take and show are the actions. Okay. Now, what
Correct.
is the difference here is, let me write. Okay. Type. This is a RDD format. All good?
Yeah, that is RDD. Yeah.
Okay. This is DataFrame.
Uh-huh. So data frame is something looking like a table now.
Because
Tables.
it is like SQL.
Correct.
All good? So you see a big difference on how we can query this data now using
Correct.
Spark
Yes.
SQL.
Hmm.
Okay. Now we are not going to do any of those filter operations and all that. Instead, we'll write a select statement. Select star from BT where city equal to Boston, month or year equal to 1996. Show me 10 rows.
Okay.
All good. So let's do that exciting query, which is what we already know from our life, RDBMS life, where year equal to, let's say 1996. Okay. But I want to see 10 rows. So
Okay.
now because it is a SQL, right?
Select. Yeah.
Select star from BT where year equal to 1996. See, instead of doing the filter operations, I'm doing it inside the SQL now.
Yeah. This looks much better now.
And it is
Compared
familiar
to
format for you.
familiar. Yeah. Correct.
Okay. Now, what I would like to do, I would actually like to do, okay, you cannot do clear screen. What I would like to do is where end month equal to, let's say July. Okay. Order by day. And show 10.
Oh.
Obviously, I'm filtering it out and only keeping 10 rows there.
So in the background, right, we are all doing this on a file, basically.
Exactly.
Ultimately, like on a very
Initial
lower
file
layer.
was loaded into RDD, and it's actually doing analytics on the file.
Correct. Yeah.
So you see, that's the beauty of Spark SQL.
Yes.
Okay. Okay. Now let's do one other operation. I would like to show you this, and then we'll conclude this topic, and then we'll see some more options with the data frames. Okay.
Okay.
Now here, I would like to do the Spark SQL. Obviously, we already declared the Spark SQL. What Spark SQL I would like to run? I would like to select year, minimum average temperature, maximum average temperature from BT, where year between, see now it all looks like SQL itself, right? And then group by year, order by year. Okay. And then you're doing a collect, print and all that. Instead I'll just do show. Okay. I'll just put this whole thing in one line. So we are taking it to next level, right?
Correct.
Okay. So now instead of just giving me individual rows, I'm just doing finding out what is the minimum and maximum temperatures.
Yeah.
Okay. Now you see the job became a little bit bigger. You see how many stages it is run, how many steps it is running in.
Correct.
Okay. Now let me explain something here. I would like to actually explain this as a RDD on DataFrame. Okay. So I would like to just say, for example, this is a map operation. Or let's not do this. Basically, we'll only look at this one as a filter. Correct?
Okay.
Okay. So this is a map. You're saying take these columns. That is a map. Initially, remember how we wrote our map here, split and map.
Yes.
For explanation wise, you see what we did here is a map.
Mm.
And the filter was basically pick whatever rows you want. That was the filter. That is what we did here.
Okay.
Okay. Then there is another concept which we did not look at earlier was, can you guess what this is?
This is group by error.
So in Hadoop world, there is something called map reduce.
Mm-hmm.
So this is a
Correct.
reduce.
Yeah. Okay.
All good?
Reduce. Mm.
So you're mapping the columns to whatever format you want. You're doing some transformation filter, and then you're reducing the data and generating a output what you need, like the average temperatures, min, max.
Mm. Mm.
All good?
Okay. Yeah.
Okay. So what we did so far is we ran from Spark 1 to Spark 2, and then we introduced the data frames also during the whole setup. Okay.
Yes. Yes.
So what else? I mean, this is what a data frame looks like, API wise, and it is very very
Correct.
powerful because the way we interact with the data has completely changed. Okay, it's in a flat file right now. What
Correct.
if we were able to take this to the next level and we were able to, do some data loading from Cassandra and then do the same things? And obviously,
Okay.
min and max are possible with Cassandra, but you cannot do it on large amounts of data. Okay, so what we discussed so far, all our data was sitting in the flat file. But in general scenario, our motto is to have the data in Cassandra, load it into Spark, do our analytics, store that back into Cassandra. That is our motto. Okay.
Yes.
Now let's open a website. I would like to go to spark.apache.org. Spark.apache.org. Okay. So initially when they created Spark, remember that they created it keeping Hadoop in mind. So in those days when they created Spark, the only big issue at that time was HDFS is very good. Hadoop file system was extremely good. But the problem is with MapReduce. Okay. So they used to load huge amounts of data and then process it and then store it back into HDFS. And then if you go look at some of the new videos on YouTube, you can search, you can find why MapReduce is slow. Okay.
Okay.
So what it used to do is it will load the data into memory. It will load the data from files. It will do the processing and it will store it back into files. Then for the next stage, during that whole, I said transformations, right? It will load the data back in from the files.
Okay.
So that file system became very problematic. It keeps on reading from the files and writing back into files.
Okay.
Okay. Now, in those days, they said, you know what? Even though system is okay, it's not performing well. What if we can do more operations in the memory? Let's use Spark. Let's load data only once, do all the processing in memory, then write it back into the hard disks, right?
Okay.
If you very simply take that thing, by default, when you put it in memory, it becomes 100% faster. So that's the speed comes, right? Then what they did, when they started creating Spark, they said, okay, we'll have a Spark engine. Let me draw things here. Okay. So I'm on the Spark website. You see, this is the Spark engine, main engine.
Yeah. Okay.
Then they said, whatever data is coming in, you can process in Spark engine. You can use Spark SQL to process it. You can pump in data using Spark streaming. You can do machine learning. You can do graph. Okay. Now, where is the data coming from? Data has to come from somewhere, right? So if this is
Correct.
the Spark engine at high level, they said, okay, you can load it from Hadoop. I'm loading it. So that's why I'm showing you the angle. Okay. So you can load
Okay.
it from Cassandra. You can load it
Yes.
you can, I don't know if you store data in HBase, but you can use HBase also, Apache HBase. I
Okay.
think it's a database.
Hmm.
And then you can run Spark on Mesos or Kubernetes. Okay. But your
Okay.
data can come from HDFS or Cassandra. So on the day one itself, they know that Spark and Cassandra is a best fit. For us, for we who are coming from Cassandra world,
Hmm.
we know that this is a combination created from the day one.
Okay.
Okay.
Yeah.
Now, to work between these things, you need a connector which goes back and
Correct.
forth. Okay.
Correct. Yes.
Now that connector is written by DataStax guys.
Okay. So
So
that is purely from DataStax. That Spark
no,
connector.
no, no, no. No, it's open source. Hold on.
Ah.
Initially, DataStax wrote that. Okay. So it's an open source project.
Okay.
So how do you find it is, I would just go to Google, Spark Cassandra connector. Okay. So that's how you find it. So this is the GitHub page. Okay.
Hmm.
Now let's say you are very good at writing Scala, you are very good at writing Akka, you are very good at writing Java. You can get this source code. Source code is just published here, connector.source or driver.source. And then you can understand the source code and then you can use this connector. Okay, you can
Okay.
actually develop connector. So a lot of people who work at DataStax, they contribute to this connector. But don't get me wrong, all over the world, whatever big companies are there, like Russell Spritzer, he works at Apple.
Okay.
Okay.
Hmm.
And you see last pickle, in
Yes.
this contributor list, there will be, see, there are 92 contributors to this project. And a lot of these people are independent. They're not related to DataStax.
Okay.
At some point of time, they might have worked at DataStax. Doesn't mean that they work today. But DataStax has a very big contribution to this. Like see this JSEC, very nice guy. He works on Spark.
Okay.
Okay. So here you will see people who are working on Kafka, Spark, Cassandra, and then overlapping. Some people are writing Cassandra-based code. Some people are writing Spark-based code. But this is a connector which is being developed by all these people. And you see Russell is the most active here.
Correct.
Okay. Russell works at
Yes.
Apple right now.
Hmm.
Okay. So this is our connector, right? Now, just simply putting, there is a lot to get this connector working for you.
Okay.
Okay,
Yeah.
on your cluster. So what I'm doing is I have started a new effort on this. You go to my GitHub, okay, which is
Okay.
Sharma 1807, GitHub/Sharma 1807. And then you can find this Spark Cassandra connector project.
Okay. Okay.
Now, I'm not trying to replicate any of what they do.
Hmm.
I have some instructions on how to build your connector on your own. Okay. Now, at the end, connector is just a jar file, one jar file.
Okay.
Okay. So what I'm doing is now onwards, I'll be publishing my compiled jar files to this particular project here. So
Okay.
just 2 days ago, I uploaded one file. And if you notice, let me click on this. Okay. You see the jar file name. So it is Spark Cassandra connector, assembled jar, version so and so. This is the actual commit version of the GitHub. If you see the GitHub has a commit version here. Okay. 065B. If you see the
Yeah.
last four. So this
Yes.
is 065B. And I compiled it on 1st of January. And there is a jar file. That's a jar file you need. Okay.
Okay.
So
Okay.
you will just simply go download this file. And I think it's a download is right here.
Okay.
Okay. That's a 13.8 megabyte file. You download it. Okay.
Okay. Hmm.
Now, instead of me teaching you how to compile this jar and all, I thought I'll give you a jar. You need that jar. That's all you need. Let's jump back to our Spark and Cassandra topic, where you have a 6-node cluster. Both are running, all 6 nodes are running both Spark and Cassandra. Okay.
Okay.
Or you can have multiple data center. Let me actually show you my setup. Okay. So let me, first thing we'll exit from this previous shell. You know how to exit is quit. Okay.
Yeah.
So this is how you quit from your Scala shell.
Yes.
Okay, let me clear screen. Okay, I'm going to do a node tool status. This is my Cassandra 6-node cluster. I want to show you how it is distributed across 2 data centers. And if at all any down nodes are there, I'm going to fix them. I know that there is one down node here. And then I'm going to start my Cassandra. Okay, so let it go on. While that is going on, you have one Spark master. Okay. Now, what I did here is on this particular server, I created a Spark Cassandra connector folder. Okay. So this is the folder I'm in right now. Spark Cassandra connector jars. Then what I did, I downloaded the jar file I was showing you earlier from our GitHub.
Okay.
Then I created a soft link for that. So I see I created a soft link pointing to the full path of that particular jar.
Okay.
Okay. Then what you do, so this is a jar file you're going to load in your Spark. Whenever you start your Spark, you're going to have this jar file in your path. Okay.
Okay.
So what happens every time Spark starts, I want it to start along with this particular jar file. Okay. How do you configure that? There is some file somewhere which will contain this jar location. Okay.
Okay.
Okay. Now remember this jar again. You have to provide this jar, place it on all nodes in the same location. That way you can have same configuration on all nodes of your Spark. This jar file is for Spark, not for Cassandra. Okay. You remember earlier when we are doing that Spark configuration, we place the Spark. There is a Spark defaults conf file. Okay. So let me show you my conf file, which is located here. Okay. So you can see Spark has the current Spark folder. There is a configuration folder under that. It is sparkdefaults.conf. That is the file I'm looking at. Okay.
Yeah. Yeah.
In that file, we made entries. These entries, you remember we making it in the initial Spark configuration. Yes. I added one more extra line here, which tells you these are the Spark jars I want to load every time Spark starts. Spark.jars, and this is the jar file. Okay. So remember, I'm actually pointing this to a soft link. So when you get a new jar, you're going to replace the new jar and point it to the new jar using the soft link. Your Spark configuration itself doesn't change.
Correct. Yes.
Now you need this entry on all your nodes, Spark nodes. And now Spark actually, when it is starting up, it will load this jar into its memory. Okay. Okay.
Yeah.
So all you need to do is go to GitHub, my GitHub, get the jar file, place it on all nodes, create a soft link, add an entry to sparkdefaults.conf.
Correct. Yes.
Done. That portion will take care of configuring the Spark Cassandra connector. Okay. Now let me go back and check if my node tool, the Cassandra itself came up or not on the down node, because I want to have all nodes running so that way you can do our analytics properly. Okay. Now I have my Cassandra running. I have my Spark configured. Now what you need to do other than that is wherever you're loading your Spark shell from, you're going to use some config files. Okay. Because we want to tell where our Cassandra is running. I have 3 config files here. Okay. So let's review each of them. Okay. Okay. Now, First one I have here is for RDD methodology.
Okay.
So what it does is basically it stops the existing Spark context. It loads some required packages. Okay. It starts with creating a new Spark configuration. Okay.
Mm-hmm.
In that, I'm saying this is my Cassandra host, and I gave you
Okay.
2 IP addresses of Cassandra hosts.
Yes.
They're supposed to be from the same data center. Okay. Then,
Okay.
if at all you have enabled authentication on your Cassandra, then you need to provide the username passwords.
Okay.
Remember that configuration file is now containing a password, so it's up to you to secure this file.
Yeah. Okay.
Then
Yeah. Yes.
sometimes you need high amounts of keep alive, timeout settings and all. You can readjust these things according to your environment.
Mm.
Okay. Now,
Okay.
once you have all these settings done, what I'm trying to do is for the read and write consistency at Cassandra level, I'm just picking local quorum. But you have a
Okay.
choice. Let's say, for example, you want to use 2 or 3 according to your environment. Okay.
Okay. So this is good. I mean, even for Spark also, you're telling consistency level.
No, this is Cassandra settings when coming from
Uh-huh.
Spark.
Okay.
Got it? Imagine
Yeah.
Spark is your application now.
Mm-hmm. Yeah. Yes. Okay.
Okay.
Yeah. Yeah.
So
Good.
I'm saying, okay, when Spark is writing data to Cassandra, what is the consistency level it will use? And
Mm-hmm.
also when Spark is reading data, it has
Reading.
to use some certain type of consistency.
Okay.
All good? Then
Yes.
what I'm doing is using that configuration I just built, I'm going to spin up a new Spark context and attaching it to the Spark master. Okay. Back to Spark context. While creating Spark context, I'm telling use this configuration I just declared so far. Now I'm making Spark aware of my Cassandra along with the IP addresses, port numbers, and this is the username password to connect to Cassandra, and then attach this particular process to Spark master.
Okay.
All good?
Yeah.
Then I'm going to print what jars are loaded in the Spark. And then from Spark context, there is also list jars command. So there are 2 ways to print Spark related information. And then I'm also saying print all the configuration which I'm using inside the Spark and then print the date.
Okay.
Okay, this is the RDD method. So Spark shell.config is our RDD method. So these are the entries for the Spark shell config.
Okay.
Okay. Now let's review another config file which will look similar with little bit of small differences here and there. Okay. Now that will be Spark shell data, SQL. Okay. So let me say SQL.config.
One note here.
Yeah, go ahead.
So these files actually are there, right? They came with the software installation.
No,
You
no,
didn't.
no, no, no. These are our own configuration
Naming
files.
conventions.
You
Okay.
need them to,
Okay.
to start your Spark shell. While loading that Spark shell, I'm going to use these config files.
Okay.
Now, what you're looking at is a similar config file, but a little different one. This one is configured for using DataFrames. Because I was showing you, right, RDD method, DataFrame method, and then there is a Dataset method. Each of them have little bit of differences in the config file. Okay.
Okay.
Eventually, we want to use only datasets. We don't want to use anything else. Datasets is the latest format.
Okay.
Okay, but I want to show you all the possible configurations. So here again, you can read this comment here. It says for Spark SQL with DataFrames method, I'm loading few required packages. Okay.
Okay.
You don't need to understand why I'm loading those. I'm just saying these are the required packages.
Okay.
Now here they introduce something called catalog. Okay. So what you see is a little different formatting here. I'm creating a Spark conf and I'm setting this parameter called Spark SQL catalog. I'm calling the catalog as CASDB1. Okay.
Okay.
What it just means is I now onwards, I am connecting to this particular connection, Cassandra. Okay. The
Okay.
catalog is nothing but this is the database. This is the type of the database. So you can say you can have an Oracle catalog, just for example. You can have a MySQL catalog. I'm saying this is a Cassandra catalog. So Spark DataFrame API now knows that, okay, you are reading Cassandra,
Okay.
reading and writing to Cassandra, and this is your Cassandra host.
Okay.
And obviously you need to tell what is the username, passwords, and any of the timeout settings and the quorum level setting, consistency settings. And then same as previous, right? I'm printing what jars are loaded, what is my configuration in this Spark, and print the date.
Correct.
Okay. This is your Spark shell with DataFrames.
DataFrames. Yeah. Yes.
Okay.
Yes.
Then I created another configuration file, I'll just do it this way. I created one more for Datasets API. Okay. This one is a little bit more detailed. What I did, because I spent more time on the datasets, because this is our future. This is the config file we are going to use for all our dataset operations.
Okay.
So this one is for datasets using Spark SQL. These are the required packages. Okay. If you need to configure more Cassandra connection parameters, you can go to this particular website to check what parameters are available. That's again documentation and directly from the Spark Cassandra connector original source code. Okay. Then what I'm saying here is, okay, as I said earlier, they introduced catalog. So I'm saying this is my catalog and this is Cassandra catalog. Okay. And catalog name is CASDB1. Now, if you read a little bit here, you can actually connect to two different Cassandra clusters, join the data from two different places, or write data, read data from two different places. That means you can declare catalog CASDB2. Okay. Now, for each of this catalog, right, I'm also saying this is my default catalog, meaning every time I run a query without telling which catalog I'm running against, it will go against CASDB1.
Okay.
Then what I'm saying, my Cassandra for CASDB1 connection is running on this cluster, this particular two nodes.
Okay.
Okay. And also you can say either IP addresses or IP:port, IP:port format. Okay.
Okay.
Username, passwords, simple, straightforward. Here things have changed a little bit. So what I did is the keep alive connections, keep alives, timeouts, all those things I reduced a little bit. And also consistency levels are adjusted, like, 2. When I'm writing it to 2, but reading is local quorum. Okay. But again, according to your environment, you're going to tweak these things. Okay.
Yeah. Okay.
Also, there is one parameter here, interesting one, called throughput. So you can read and write and you can throttle it. Remember, there are throughput throttling options. Here, I found that you can also throttle, let's say, for example, when you're doing an input, which is reading from Cassandra, you want to not overwhelm Cassandra. So you want to read only little bit at a time. So I'm saying throughput per second, MB per second. So that means it is going to read only 1 megabyte per second. Okay. Same way, when I'm writing to Cassandra, I don't want to write too much data to Cassandra at once. So I'm going to throttle it. Okay. And also notice that these parameters I actually commented out. I'm not using them right now. If at all we need to throttle, then we can enable that and adjust the parameter. Okay. Then some more parameters you can read about is you can explicitly set the port. You can say this is my local data center, whatever is the data center. And then you can set timeout settings. Default is 5 seconds. So I left it that way. Finally, I print my information about what jars are loaded, and then also show me all the configuration I'm using. and then date, and then that's it. That's the configuration file for datasets. Once you have one of these configuration files, what you do is you are going to load your Spark shell. Okay. So your Spark master is running, no change there. Your Cassandra is running, no change there. You have a jar file which you put on all nodes. That jar will allow Spark to connect to Cassandra.
Correct.
And then you created config files which will allow you to specify what Cassandra you're connecting to.
Okay.
So with all that information, I'm going to load my Spark shell. -I, I'm telling what is the config file to use for this connection. Once you have one of these configuration files, what you do is you are going to load your Spark shell. Okay. So your Spark master is running, no change there. Your Cassandra is running, no change there. You have a jar file which you put on all nodes. That jar will allow Spark to connect to Cassandra.
Correct.
And then you created config files which will allow you to specify what Cassandra you're connecting to.
Okay.
So with all that information, I'm going to load my Spark shell. -I, I'm telling what is the config file to use for this connection.
Okay.
Okay. So now I'm starting my Spark shell. So now what is happening is using that jar file which is loading in the background. That jar file will make Cassandra APIs available inside the Spark shell. So now I can say, hey, you know what, read that particular table. So this one will take a little bit of time. It's okay, because it's now spinning up Spark related resources, and it is also establishing connections to your Cassandra and all that.
Correct.
So it's like, you know, allocating memory, executors, all that, whatever Spark has to do in the background. So I'm going to use SQL shell. And what I'll show you is I have a sales key space in Cassandra. Use sales. I'm going to clear screen. Describe tables. We'll see a bunch of tables. Let's say select star from sales dot products, and then I'll say limit 5. Okay. Bunch of products in your database and their product category, price, all that stuff. Okay. Pretty straightforward stuff, nothing special. Going back to the Spark shell, it is still loading. So while any Spark shell session starts, what it will do is it will create a Spark context, which is the SC, is available as SC. You can see this particular line you can read.
Correct.
Spark context available as available as SC, whereas Spark session is available as Spark. Okay.
Okay.
So small thing here, you know, when they did the RDD to DataFrame APIs, RDD was using SC. So whenever you write SC dot, you can imagine it is running against RDDs.
Yeah.
And when you do Spark dot, it is actually Spark SQL. So that is all DataFrames.
Okay.
But they're all running under same umbrella. That means you can take a RDD, convert it to DataFrame, take a DataFrame, convert it to RDD, and then you can go back and forth. So in this particular case, you need more CPUs. Basically, it just sits there and trying to allocate all the required resources for your Spark. Okay, so finally our Spark shell loaded, right? Well, let's discuss on what happened here. So you started Spark shell along with this configuration file. From here to here, it's all Spark related messages. When Spark shell was starting, so it created a Spark context, SC, Spark session available as Spark for you. Then you remember inside the config file, I wrote, okay, tell me what Spark jars are loaded. Okay.
Yes.
So this is the Spark Cassandra connector. Remember the soft link I created? That is the jars which are loaded. Okay.
Okay.
Then I'm telling print all my configuration settings. Now you can actually comment this out. I'm just printing it so we know how many hosts we provided for Cassandra. And let's say what drivers are using, what is the timeout settings, where is the Spark master, how many executors are allocated on this node, what is the Cassandra username passwords, what is the consistency levels we are using, and then what is the port for Spark and what is the port for Cassandra. I mean, here port is not specified, so it is using default port.
Okay.
And then you see any other settings. And then I also told it this is just a warning message or whatever message it was printing. That is not from my config file. And I said, okay, print me the date, current date. Okay. So then it came to the shell. So this is your Spark shell, basic Spark shell, which we saw earlier. Only difference is now using that jar, Spark has knowledge to connect to Cassandra. It knows where to connect, which Cassandra cluster to connect. And when I do sc dot some Cassandra APIs, it knows how to read the Cassandra tables. Okay. Simple. So now if I do sc dot Cassandra table, sales products. So what you're saying is, okay, this is my table. You're not telling anything like, count, or you're not doing anything. Imagine this is your transformation. You're telling sc dot Cassandra table, sales products. Okay. Similar to loading the text file into memory.
Yeah, correct.
So notice what it did. It took data stack Spark Cassandra Spark connector RDD. It created a special kind of RDD called Cassandra table scan RDD. That will result in terms of result, instead of coming as string, it is saying it's a data stack Spark connector Cassandra row.
Okay.
Okay. And then you see Cassandra table scan RDD. How many partitions?
0.
Because it did not load anything. It did not even go to check with Cassandra saying, hey, do you have this table or not?
Okay.
You just declared there is a table. Okay.
Yeah.
So that declaration resulted in res1, which is a scan RDD. So I can do res1 dot count. Tell me how many rows are there in the table.
Yeah. Now
this is your action.
Okay.
Okay. See, most likely the simplest thing any Cassandra DBA will have, first request will be, there is a large table. I need to copy it from table 1 to table 2. That is one of the requests which will come. And your copy command, dump commands, SS table load command, all those commands are very difficult to work with. So I love this method where you just call one Spark one-liner and it will do the copy for you.
Okay.
Okay. Obviously, it is a little bit heavy operation. It's going to Cassandra. Cassandra has already the table distributed into multiple partitions. So it has to understand how it is partitioned. And then equivalent RDD is created in memory. It loads the data into memory, do the count, and then give you the result. The count here is not running on Cassandra. It is running in Spark.
Okay.
Okay. But remember that it has to load the data into memory. That's what is going on right now. And you can see the stage 0 is running. I'm not sure if it is multiple stages. Right now, stage 0 is running. Okay. So you see this second number in the bracket, which is reducing right now. Okay. So what you see, notice that output came. Okay. So what it did is it took your job, which is like the whatever dot count. It creates stages because it has to understand how many stages it requires. So Spark driver will say, okay, stage 0. what is that I want to do is, I need these many executors. That is your parallelism. Okay.
Okay.
This is how many completed so far. This is how many is total. So you can think of these as tasks.
Yeah.
In stage 0, there are 56 tasks. 4 of them are running in parallel right now, and 52 are done.
Correct.
When it is done, it is going to give you this result. Let me show you how you will take some data, do some filtering, and what your regular stuff you need to understand. You're saying sc.cassandra table, read from this key space. This is the original table you need to read, and then save it back into Cassandra, into some other key space, some other table name.
Okay.
Simple. This is RDD method of taking a table from Cassandra and storing back into Cassandra.
Okay.
Imagine this is your copy command.
Yeah.
That's all you need to do.
Hmm.
Pretty powerful, right?
Doesn't matter how many rows it is having, right?
Exactly.
1 million, 10 million, it's one single client.
Yeah, it runs in a large time. It is a big task. It will run it and it will finish the job. So I want to show you some other stuff here. Okay. So what we want to do is, first of all, we'll go back into Cassandra, and I want to show you if we have a table called products2. Okay. I'm going to truncate. There is a table I created called products2, which is a copy. And then I just want to truncate that for now. Oh, sorry. I want to just do limit 5. Okay. So you see products2 table is empty. Okay.
Yeah.
Then what I'm going to do is I'm going to explain this code for you. Okay. So first of all, sc.cassandra table, you know what is that? You're reading the sales products table.
Correct.
Okay. Take a sample and just pick up 10 rows from it.
Okay.
Okay. So what I'm saying is, take sample can do like percentage samples or something like that. See, if you have 1,000,000 rows, I want to take a sample of 2%. You can do that. Here I'm saying just give me 10 rows. Okay. Actually, I can run this and show you what happens in the output. Okay. So for example, take 10, or let's just run this and see what happens. Take sample, right? I'm sure it will result in a RDD. So now what it is doing is it is going to sales products and picking up 10 rows from the table in Cassandra.
Yeah, here we cannot show, right? Dot show won't work.
I did not run it. No, show is for DataFrames.
Correct. Yeah.
I did not even do any action. I mean, take sample itself is action, but I'm not printing it on the screen. Okay. So take sample itself, convert it to Cassandra rows, but it is array of Cassandra rows. You can see the rows came out actually. Okay. So what I'm doing here is I'm just taking 10 rows. Dot count, if you do, it will tell you how many rows came out. Okay. So I know these operations are difficult. Now count itself is not allowed on this method. Okay. You take 10 rows, parallelize them into Cassandra memory as RDD, and then save it back into a new table. Okay. So this parallelized thing, I'm not going in detail right now. Just forget about all that, because it created an array, but I want a RDD. So that's the reason I parallelized it. Okay. So if you run this code now, what you're doing is you're actually reading. So just focus on what you need to understand. You're reading this table, taking a sample of 10 rows, converting it to RDD using this parallelize method, and then saving it back into a new table. So here I'm taking 10 rows, but you can take 2% of rows. Okay, that is possible.
Okay, yeah. Yes.
So what it is doing is, here output will not be displayed and nothing is there. It just saved it to Cassandra table. To check, we can go back here and say how many rows got loaded. Okay, you can actually just do a count. So let's just do count of 1, and then I'll get rid of the limit here. So there are 10 rows in the table now.
Yeah.
Okay. Now what I can do is I can also truncate. Okay, let me do a select star from, that way I can see what data is there, just to make sure. You see all columns got loaded
Correct.
from products table to products 2 table. Okay.
Yes,
Let me truncate sales dot products to, not the original table. You always are working on the copy table. Okay. No, you don't have any data. Okay. Next step I want is, I want to take the same example we are using earlier, but instead of doing all columns, I want specific columns. Okay, so let me explain how this works. And then I'm going to do take sample. Explain that later. Okay, so first piece I want to explain is this. You're just declaring this is the table you have, key space table name.
Okay.
Out of that, you want only these 3 columns. Take a sample, meaning pick 10 rows.
Okay.
Parallelize, I was explaining it a little bit earlier. So basically this particular method, right now, this particular transformation and collect, or the action, will give you an array of Cassandra rows. But you don't want array, you want RDD. So I'm converting it using that parallelize, I'm making it RDD.
Okay.
Then the resulting 10 rows, save it to Cassandra, to this table, key space and table. But you see here, I don't have all columns. I have only 3 columns.
Okay.
All good?
Yeah.
Okay. So now let's run this particular code on our Spark shell.
Okay.
Okay. So here you can see I'm doing a little bit more than regular stuff. I'm in Cassandra, I'm picking up 3 columns and storing them back into another table. Okay. Nothing fancy. It's just a insert into with some columns. As you go, as this becomes more complicated, you cannot do it in Cassandra anymore. You have to have Spark to do it.
Correct.
Already, I think by this time, Cassandra cannot handle it because of the table sizes and all. Okay. So it's doing whatever I was explaining, right? Stages. You see stage 8, something going on. Okay. Now it did that. And if you go back and look at the table, your partition key obviously need to be there. It is there. And then all the other columns which we did not provide became nulls. Only columns which we need became values. All good?
Yeah. Okay. Good.
We read 3 columns, we return 3 columns. Now, imagine this products 2 table does not contain any other columns other than price and quantity on hand and product ID.
Okay. Okay.
So that means it's a big transformation. You are actually taking from one format of table and writing it into a different format of table.
Correct. Yes.
Already doing a huge thing.
Yes.
Okay.
Yes.
Now let's add a little bit more to this particular existing query we looked at. Okay. I'm just going to clean this out and write a new one. And then also here, what I would like to do is to truncate the table again, right? I just want to clean up. So we only look at the new data always.
Yeah.
Okay. So here you don't have any data now. Going back into my notepad here, notepad++, I'm going to explain what we did here. So same thing as previous. Okay. I'm reading a table with 3 columns, but adding a where clause to it.
Okay.
Okay. Then saving the data back into the table. Okay. So what I'm doing is where clause where product ID is equal to 33. There is a specific row I'm picking up using that where clause.
Okay.
Okay. So what is happening now is it is going to go to Cassandra and say select product ID, comma product price, comma product quantity on hand from sales.products where product ID equal to 33. That is what it is running on Spark. I mean, sorry,
Okay.
from Spark, it is running it on the Cassandra side.
Cassandra.
Get the data
Hmm.
and then load it into the other table.
Okay.
All good?
Yeah.
Not a very difficult thing to understand. Yeah, you're going to ask.
Can you go back to Notepad?
Yeah, sure.
So anyway, we are loading 3 columns. So can I skip that some columns option in the
No, you cannot.
line?
This one here, right? You're talking about this particular thing. No, because the destination table has more columns. So Cassandra will expect values provided for the all columns, right?
Okay. Okay.
So you are saying some columns, I'm only storing these columns. So do not expect all columns to come in.
Okay.
That's the reason you need to have it. Okay.
Hmm.
Okay. Now let's go back here and let's run that particular statement on Spark. Okay. Again, it will create a stage. In this stage, how many tasks are there? How many parallel should run? How many jobs should run? And finish the job. When it is done, you end up with only one row. But the main idea here is to explain you how to do a where clause with RDDs. So I'm first showing you how to pick only some columns. Now I'm showing you how to pick some rows.
Correct.
Okay. Now let's do a little bit more. Okay. So these things you already know, but I'm just going to run them and just quickly explain what it is. So same thing again, reading that table, 3 columns, where you're writing a little bit of complicated query here. You're just saying read these 3 different partitions with the partition keys and then save them back. Okay. Remember one thing, so far we are still using the partition key. So there is no big deal, right? You can do this in Cassandra also.
Correct.
Okay. But then you have to learn Spark. That's why I'm showing step by step. Okay. So now we execute that. It's doing some stage, something. I don't care what it did. What it did was it read that 55, 66, and 77 entries and loaded it into our table.
Correct.
Okay.
Yes.
All good. This particular thing will not work because I think the optimizations are not written. See, for example, if I do product ID in works, right? But if you do a product ID less than 10 or equal to 10, will not work.
Okay.
For some reason, it's not implemented because Cassandra itself restricts on what you can run on Cassandra, right? Because of all the things we learned about, what you should not be doing in Cassandra, like partition keys, supposed to use them properly. Okay.
Yes.
So now let's move on to the next place where I'm going to take this and I'm going to save it. Okay. So first of all, what I would like to do is select these 3 columns. Okay. I'm just going to clean this out as a select statement from sales.products, right? I'm writing actual SQL command just to show you what I'm doing from sales.products where product category is computers. Do you know if this will work in Cassandra directly? If I run this, will it give error or will it work? So first question you will always ask is what is your table structure? So your partition key here is product ID.
Correct.
Okay, there is no more index, no other indexes available, and there are no clustering columns. So when you run this particular query where product category is computers, it will just say, hey, you know what? I cannot do this. But you can definitely use allow filtering here. And we always tell them, do not run this. because allow filtering is not the correct way to do it.
Yes.
Okay. Now, what happens is your application team comes to you and says, hey, you know what? Pick this table, take these three
Okay.
columns. This is my where clause. Load the data into somewhere else.
Uh-huh.
How will you do it? Okay. Now,
Okay.
instead of taking a sample, I can take like 1,000 rows, 10,000 rows, 100,000 rows, whatever, right?
Okay.
So what is not possible in Cassandra is that product category equal to computers. There is no index that is not part of partition key or the clustering columns.
Yeah.
That's why I want to use Spark to do it. This is first time you're looking at an example where Spark is necessary, not just option.
Exactly. Now this is the place I'm witnessing, like Spark is necessary now. Yeah, correct.
Correct. Okay. So I'm going to copy this, paste it onto, okay. First of all, in the second table, I want to see if the data is there or not there, because I want to show you, we can truncate this. Okay. Let's leave it there and then let's run this. Okay. Now, only thing is I'm not writing the product category back, so I cannot prove it when it runs, but you just have to assume that product category is computers.
Okay.
But you can see okay, here again, quickly, stage 15 was running with 56 tasks, 20 finished, 20, 30, sorry, that's very difficult to explain while it is running. Let it run, but you know the concept. It is doing a 24 as a partition, as a distributed parallel computing.
Correct. Correct.
So 24 tasks parallel. Okay. So stage 17, it is doing something, I don't know what, but it is doing some kind of operation. And then at the end, it is going to save all the output to the table. So it is now picking up all the products which are fall into computers category. So you can see it already started writing data. What I'll do is I'll do a select count. Okay. So you can see it is already pumping data.
Yeah. So you get to see such requirements. You know,
Yes.
people are asking you to give the, you know,
Yes,
where
every
condition
single
on a different columns.
Every single day.
Okay. Yeah. So because they're not duplicating the data. So because they have Spark.
No, it's not even duplication. Forget about duplication, right? See, for example, your management wants some reports. They'll say, suddenly they'll come and say, hey, you know what, there is this user. Your partition key is not user, but I want to give me all the things they did yesterday.
Okay.
In Oracle, you'll write very simple select statement and put it in an Excel sheet and send it out.
Yeah.
So what we have to do here is either we write it back into another table, so developer can take it and write as a report, or you can actually get this data and save it in a text file.
Yeah.
Because it's all Spark now, right? Once the data got loaded into memory, you don't have to save it back into a table. You can actually give it as a file.
Okay.
So you can see the result now, 2600 rows. So it loaded some data from a previous place to new place.
Perfect. Yeah.
Okay. So I think so far what we discussed was all RDDs, and we are taking data from Cassandra, loading it into Spark as RDDs, doing some stuff with it, and then saving back to Cassandra.
Correct.
But this old method of RDDs is very old and cumbersome. You saw how much code you have to write as a RDD itself. You say it's not like a SQL command. You have to do magic like this. Okay.
Yeah.
Not very clean. It's more like Java development. Okay.
Yeah.
So let's move to the next method, which is DataFrame method. I'm going to quit from my shell. Let me know if you have questions while I'm doing that.
Okay. I have one question. To do all that step, right? Like the product.to table is already existing. So
Correct.
that is mandatory now. I mean, you have to have
Yeah.
it.
So I'm assuming that your a destination table is pre-created in Cassandra.
Okay.
There are ways you can actually have Cassandra command run from Spark, like you'll create a table from Spark. But as a Cassandra administrator, you can create it with Spark Shell, easy.
Correct.
Yeah.
And one more thing,
Mhm.
those keys no need to be same, right? Your
Correct.
products and product.
You
Yeah,
don't
then that is good.
Yeah. So
Yeah.
I'm totally using Cassandra's power as if Spark is an application.
Yeah.
Now
Yeah,
what
yes,
I'm going
yeah.
to do, next step, you remember we wrote another config file for the data frames?
Correct.
Okay, I'm just going to start this and then we can discuss a little bit on the side because I know that Spark Shell takes time to load. Okay, so because I told you RDDs are the way Spark introduced first, right? So we looked at RDD method. Then I said, you know what, Spark 2 came, and then they introduced DataFrames that knows a little bit about schema, not just data.
Correct.
So DataFrames are much better. Okay. But now today, we are in early 2021. Spark already has something called datasets
Yeah, correct.
and catalogs. So
Okay.
these are much more advanced than even looking at data frames. So we personally, we want to know how RDDs look like. So I gave you some examples in the previous discussion.
Okay.
Now I want to show you a data frame method, but even data frames also are old. So we don't want to even look at that very keenly. Okay.
Okay. Okay.
So what we'll do, we'll look at the data frame only in the sense of understanding it, but we are not
Okay.
going to use too much of that.
Okay.
Okay. So I'm activating my Spark Shell with the DataFrame API related config file. And while it is starting, I will start discussing how the code looks like. Okay. So here what I'm doing is I'm calling it method one data frames. And in this data frame example, today I'm going to show you only one example. That's it. I'm not going to even show you how to write back to the Cassandra and all. Here what I'm doing is this is a data frame API. So you remember previously RDD we are doing SC dot.
Yes. Yes.
Now I'm doing Spark dot because I'm using Spark session, which is aware of SQL. So Spark dot read Cassandra format. I'm telling this is a Cassandra table. Notice a small flip here. This is the table name, not key space. Key space is written as a second parameter.
Correct. Yes.
And then I'm saying load, meaning take this table and load it as if it is data frame.
Okay.
Okay. And then declaring a data frame out of it. Then you remember this particular piece which we used earlier when we were doing the USA temperatures from file. We said, okay, create a temporary view for this.
Correct. Yes.
From now onwards, I'm going to call it as DCLDF. And then I can do a Spark SQL on top.
Okay. Okay.
And then I'm just declaring the output and then show 20 rows out of it. So this method is data frame method.
Okay.
Now, when you're writing data, right? So similarly, what you can do, spark.write, Cassandra format, products to table, sales, and then do something. I don't remember what you have to do, but there is a write API for that.
Okay.
Which I'm not going to even discuss today. I'm just going to discuss about how to get data using data frames. So you know how the data frame looks like, okay? So let me go back here example wise, okay? I can do a little bit changes to this, right? So I can just call it as, okay, this, and then Spark SQL dot show directly. I can do that. Okay.
Okay.
Then you can do several filtering later on, like, so for example, where product underscore category equals computers, right?
Hmm.
So once you declare it as a temporary view, you can do several different queries here.
Okay.
So now the data frames, you have some idea. What we'll do is we'll jump to the data sets. So
Yeah.
I'm going to activate my Spark shell. So I'll activate my Spark shell using this datasets configuration we did earlier.
Yeah.
Okay.
Yes.
Nothing special. It will start Spark shell. So we'll give it a minute. Okay. So whatever RDD method, whatever data frame method, right? What we would like to do is for future, we are going to use Datasets API. So what I did here, if you see Spark shell, I launched it with this config file, which we wrote for the Datasets API. Remember, Datasets is not very different from DataFrame, but it has a little bit more API inside. Okay.
Okay. Okay.
So if you look at these messages here, that is telling you Spark context is available as SC, Spark session is available as Spark. Okay. Next one is just a jar which was included. And then there are a bunch of config settings which I'm just printing for our sake, just to understand how our configs are set up. And then I'm showing you what is the date and then the Spark shell. Okay. Nothing special.
Yeah.
Now, in this Spark shell, what I did is I already declared all the connections to Cassandra and all, right? We just jump in by writing one small statement like this. What I'm doing is
Okay.
select product ID. I'm just saying spark.sql. Forget about all the other code we wrote, right? Cassandra table and all that. I'm just saying spark.sql. Select product ID from cas db1. Remember in the config file, I said this is a catalog. I'm declaring it as Cassandra. For this catalog, these are the contact points.
Okay.
In that, sales products is the table, limit 20. So this limit 20 will run on Cassandra, not on Spark.
Okay.
On Spark, I'm saying show.10, 10 rows.
Okay.
Okay. So now what I did is I did cleanup of everything. It's just in the config file. I'm just writing one straight select statement. Very easy, straightforward. I don't have to bother about, what is the format and all that. So show itself is directly an action. So right now you see 56 tasks, 52 completed, 4 running. As soon as that 4 running completes, it will come back. Okay, it went to stage 2 or stage 1. Now it's supposed to show you the result.
Okay.
Okay, I want to explain something here. Now, even though you are still working on data frames, but using Dataset API, you can also do one more thing because Spark SQL also can explain what it is doing. Just like Oracle explained.
Okay.
There you go. Okay. So if you look from bottom up again, anytime you read explain, you should always read from bottom up. So
Okay.
Cassandra filters, there is no where clause. You did not send any where clause. What are you requesting columns? Only one column you're requesting. Okay. So it is doing a batch scan using some product ID, something we don't have to understand. It is doing a Cassandra scan on this table.
Yeah.
Then it is getting all that and it is calling this project and collect limit is 20. Okay. Meaning this limit 20 was not executed on Cassandra. Instead, Spark was doing the collect limit.
Okay.
Okay. And then you got the output. So you see, this is the physical plan for this particular SQL we executed. Okay. Now, let me clear the screen. Let's look at one more example. So same query, I would like to create a data frame instead of me, just running the SQL and looking at the output. I want to create a data frame. So when I say val df my df, so what it did is it is reading product ID. It's a big int. Okay. But here I put a star, so it's reading all columns.
Okay.
Okay. So that's why you have product categories, a string, and 5 more fields. Now
Okay.
tell me, data frame is a combination of schema plus data, RDD.
RDD.
So schema came from Cassandra.
Mm-hmm.
And data also came from Cassandra. It created a data frame.
Mm.
All good? So that's
Yeah.
what I wanted to show you there. Now,
Oh.
because it is so easy, now you can write any kind of select statement, right? You can just say product ID from sales.products, where product ID is between 11 and 15. This where clause is kind of complicated for Cassandra. And you cannot do order by on anything. You have to do order bys on specific columns.
Okay.
Okay.
Mm-hmm.
Even though you wrote one select statement, remember that portions of it is executed on Cassandra, portions of it is executed by Spark.
Yeah.
It's not completely, that select statement itself is not running on Cassandra.
Okay.
Okay, it will decide which portions will run where.
Okay.
And then ignoring all those errors, there are some already registered Hive errors and all that, you still get the output. So even though it feels like, okay, why only 4 rows, 5 rows, why is it taking that much time? Remember that in real time, when you're doing this, you will be running on a 10 billion row table.
Correct.
Okay. So initial planning phase, even if you spend 2 minutes planning it, when you're executing the job, it will do it fast.
Yeah.
It will look good output wise. Okay.
Yes. Yes.
But overall, we are also, remember one more thing. What I'm running is on a cluster which does not have enough memory. It does not have enough CPU.
CPU.
I'm
Yeah.
running it on a cluster which is very small,
Mm.
having huge data on a small cluster without resources. So obviously Spark is suffering right now. This could be even your GC pauses. Okay, so ignoring all those errors, your SQL itself worked.
Yeah. Correct.
Okay. So now let's do one small thing here. I want to see the explain plan for this. So I'll just do explain. I want to see the plan. Okay. So when I do explain, basically it is not running anything. It's just preparing the explain plan for you to see what it is doing. Okay. So again, at Cassandra level, you did not apply any filters. This is what is very important to understand. Okay. At Cassandra level, it did not send the product ID to filter. It only said, okay, give me the data and I will do filtering myself. Okay.
Okay.
Then you see requested columns are product ID only. Then it went for a batch scan. At Cassandra level, it did a scan of this table. It applied the filter. Now, I personally think this apply filter was done at the Spark side. And then it did something, and then it did an exchange repartitioning based on what our columns came. Okay. And then it did a sort, because you did a sort where order by, and then it displayed the output. Okay.
Okay. Okay.
Why I want you to understand this is you can always use that explain to figure out whether your filtering is happening at Cassandra or is it happening in Spark. So imagine in this case, you could have done better if you did the filter at the Cassandra side instead of giving all data to Spark.
Okay.
Okay.
Hmm.
All good.
Yeah.
And also,
Yes.
when you write your select statement, Spark is deciding which portion will be run by Spark and which portion will be run by Cassandra. See, our intention was not to read data, right? Our intention was to write to this table, which was there is a second table.
Correct.
So I'll do truncate sales dot products 2. And then if you do a count, there is all gone. Obviously, we don't want that data. What I want to do is this. Pretty self-explanatory, right?
Yeah, yes.
Okay, let's run that. Okay, so what it is doing, it is reading from the products table, writing it into products2 table for
Correct.
specific where clause. Okay,
Mhm.
I'm going to go back and verify if the table got any data. Okay, so it got 5 rows. Let's look at the data by looking at select star from. And then there were 5 rows which came from the previous insert statement. Okay.
Okay. Okay.
I want to do a little bit more. What I want to do is I would like to run this select statement. See the select statement with product ID, category, product code, description, product name, product price. But quantity on hand, I want to increase by 1000 by multiplying. Column alias is again same product quantity on hand from sales products where product ID is between so and so and so and so.
Okay.
If you run this in Cassandra, what will happen?
This will time out error, I guess.
No. you see that multiplication I did on a column? Is
Correct.
not
Correct.
even
Yeah.
valid. This is not even valid in Cassandra.
Okay.
Got it?
Yeah. Yeah. Okay.
So that is the complexity here on the Spark side. What I want to do is I want to get some data which is not in the Cassandra format at all. Okay. So I want to run this. And what will, okay, sorry. This is not to be run on the Cassandra side. I want to run it on Spark. Okay. So what I'm doing is I'm declaring a data frame with that particular select statement. You can do a explain later to understand what it is doing inside. Okay. Then I want to show 20 rows out of the data frame.
Okay.
Now, you remember that product quantity on hand is getting multiplied as the data is coming in. So you are actually reading your source, you're applying a transformation, and show itself is a action.
Okay.
Okay, so it is doing whatever it has to do, stages, and then it is showing you product quantity on hand is like very high number because you multiplied it with 1000.
Okay.
Okay. Then whatever output is in the data frame, I would like to write it back into a different table.
Okay.
Okay. So I would like to write this with a append. See what I'm doing now is I'm not just writing the table back into the table, the data frame. I'm using that append format because already there is some existing data. I would like to keep my data, but also whatever data is coming in as new, I'm just going to append it to the existing table. Okay, so you see from the previous select statement, if you notice, we have only 5 rows, 11 to 15.
Yeah.
But now when this finishes, it is going to get some new data, which is in the 21 to 24, 25 range. And then it is writing it back to the table. That's why you see more data now. Because I appended, wrote it to the table. Okay.
Correct.
Now, imagine you can write this whole thing in one shot. You don't have to write it in multi-line. Instead, that same thing can be written like this. See, select statement. Okay, I have the select statement written down. And I'm just adding a write to directly.
Okay.
You don't have to declare the data frame. You don't have to show from the data frame. You directly jump to write. So what I'm trying to explain here is basically you took data from Cassandra, you transformed it, you see one column, you increase the value, and then write it back to Cassandra.
Yeah.
Okay. Cassandra itself cannot do that quantity update. Okay. Can you run this?
Update. Set. No, I think here we can do, but in general on Cassandra,
you cannot because you need to provide the partition key. Okay.
Correct. Yeah.
Let's try on Spark. All good. You got an error. Nice. Let's go and read what it is. Read only that piece. Temporarily update table is not supported. Simple. Okay. So how do you do it? My method is I'm just going to do it this way. Instead of update, we have upsert, right?
Correct. Yeah. Yes.
So basically I'll select product ID and multiply the product quantity while I'm getting it. I'm just going to increase it by 5. Okay. From the table, you got only 2 columns, the partition key and the new quantity on hand value.
Okay.
Write it back to the table. It will go do the upsert at Cassandra level.
Okay.
All good? Let's run it.
Yes.
Okay. Before running it, what I'll do here, before running it, I'll just do clear. Select star from, okay, sales dot products, where product underscore ID equals 55. Okay, that is your quantity on hand right now. I'm going to run this code, which is going to increase the product on quantity on hand by 5 and save it back into the table. It's doing an upsert.
Okay.
At Cassandra level, it is upset.
Yeah.
For Spark, it is just a select and write it back. For Spark doesn't know what it is doing. It is just selecting data and writing the same data back into the same table.
Okay.
For Spark, it just looks like, okay, I read data, I write data. I don't care. At Cassandra level, it is giving data when it is a select. When it is inserting, it is upserting actually, because those product IDs exist. So it's just updating the quantity on hand. Okay, done. Let's see if it changed the quantity. Okay, that's the end of our session. Do you want to say anything?
Okay. See, literally you played football, right, with Cassandra data using Spark.
Correct.
Yeah.
You want to call football or you want to call it rugby? I want to call it rugby.
Yeah. I agree.
You know why?
With you.
Rugby is a lot more rough.
Correct.
Yeah.
So Cassandra with the Spark, like it is a deadly combination, right?
Yes,
That's what,
it is
you always-
deadly, and I'm telling you, in market, a lot of people don't know this. What you saw today, I would say only 1% of people really do it on daily basis.
Okay.
Okay.
Yeah.
So that's all for the session. It's amazing to learn Cassandra with Spark and learning Scala.
It is great.
We did
Very
a lot.
great session. Yes.
Okay, cool. Thank you.
Yeah. Thank you. Thank you so much. Yeah.
Okay.